All yours.
We started.
Yeah. Again, this side or you want to-
Mask
No, after this is but you're not visible now.
ये लोग भी पार्टिसिपेट करें मनीष ना ज्यादा इसमें पहुंचे
जो भी
ये लोगों से इसका टॉक है
thing is required.
सेशन
ऑन चलने तो चलो Good morning, everybody. Am I audible? All right. Good morning, all. On behalf of ARIES, we welcome you all, students from Don Bosco Girls, Don Bosco Boys, Parvati Prema Jagati, St. Joseph College, Sherwood College, and Virla Vidya Mandir, students of high school and intermediate, and their respective teachers, and our Director ARIES, scientists, PhD students, media people, and all other dignitaries who are available online or offline mode to this very special program in Indian context and even otherwise, that is National Science Day, 28th of February. Every year, since 1986, it was decided that National Council for Science, Technology and Communication, they suggested that since just to celebrate the first Indian, that is Professor CV Raman, who was awarded with Nobel Prize for his very great discovery called Raman Effect, based on scattering of light. And it was a very great discovery in science, and we as Indian are proud of it. And after 86, it was decided that 28th of February will be celebrated as National Science Day. And we are gathered here to celebrate it. I welcome you all again. And theme of this National Science Day this year is Future of STI, Impacts on Education, Skills and Work. Future of STI, I believe STI is Science, Technology and Innovation. And then we are transforming that, what impact it has on education, skills and work. So as I mentioned, Professor CV Raman discovery of Raman effect is, of course, science. And since then, of course, technology has evolved a lot. And now a third term is very popular, that is innovation, that how you are going to use science and technology in an innovative manner to do something for societal benefits. And probably that's the reason that government has decided that STI and impacts on education, skills and work, because the passion, the way we utilize science, technology and innovation for society is definitely either in terms of education or in terms of skills and of course work. And this year, Government of India is also planning to have a new STI policy, that is Science, Technology, Innovation Policy, that's going on. And probably that is the reason, I guess, that the government has decided that let us try to connect it to that what is the impact of science, technology, and innovation with education, skills, and works. Because science, technology, and innovation is anyway going to be utilized either for education or for skills or for works, for the societal benefits and for the development of nation. So we at ARIES decided that it would be a very nice opportunity to take high school intermediate students, science students, and even otherwise all, but main focus was to talk to these enthusiastic high school intermediate students, because next few years they are definitely going to be asset for the country, and they will have impact on education, skill, and work. So that's how this all is connected. And with this brief background, and to start the session, first of all, as I have circulated the program, that I would like to invite Director ARIES, Professor Dipankar Banerjee, and our senior scientists, Dr. Manish Naja, Dr. Naren Singh, Virendra Yadav, to join hands and offer flowers to Raman's photograph here, just to remember him and remember the day, and light the candles before we start the session formally. So, sir, please. Thank you very much, sir, for your. Now, I would like to invite Professor Dipankar Banerjee, Director ARIES, to say a few words on this occasion and enlighten all of us on this occasion that how science, technology, and innovation is useful for, and what are their impacts on education, skills, and works, so that we can now start the later programs after we hear from Director ARIES about his views. Sir.
Thank you, Shashi. Good morning, students, friends who have joined online, and my colleagues here who have gathered in this auditorium. Ideally, this National Science Day, we prefer to celebrate with public, face-to-face interaction. What we do and what way we could help the society and the youngsters to come for science and technological demonstrations. That's the right way of doing things. But because of the extreme situations, we have never experienced this before, and I hope we will never experience this again. So we have, taken resort to this mode, which is not the most ideal, but we'll try our best to get too close to you as much as possible. But I guarantee you, those who have joined today and those who have not been able to come to the campus will be, have you, will be willing to take you any time when situation prevails. Particularly next Science Day, we would like all of you to be physically present in the campus so that we can have a much more fruitful, interactions and so on. So let me just start and try my best to give you a little flavor of, what some of us do here, and more precisely what I do in my research, and how, I'm looking forward to the next generation to participate in that particular avenue. Because 20-25 minutes is not enough to give you the overall, activities which is happening in the institute. We have different branches, and through the different activities which is planned for the day, you will get some flavor. And of course, the virtual tour to the observatories will be given by our own students, and hopefully you will get a flavor from that as well. So the basic point is, so National Science Day, see, the main objective is to celebrate the spread and a message about the importance of science used in the daily life of the people. See, why do we need science? That first, all youngsters have to first question that. To display all the activities, efforts, and achievements in the field of science for human welfare. So this is again another very important element. After all, we all belong to the society, and science is crucial for taking the society forward. And this year has been the perfect example of that, how science can sort of save us and take us to the future. So it is celebrated to discuss all the issues and implement new technologies for the development in the field of science. So as my colleague Shashi told you, that science, technology, and innovation, they're coupled with each other. So this is again another interesting aspect, that some of us do more basic sciences, but we have colleagues, we have friends who are in the engineering, fraternity. So how we work closely together, that actually, finally decides how we proceed for the next, next kind of lifestyle. So to give an opportunity to the scientific-minded citizens in India, again, this is a National Science Day, so it is also open for not only young scientists, but general public. And it is very important that we engage with the public, and that's why this attempt is to go live. We are live today through these Zoom platform, and also through the Facebook and YouTube. So please use those channels, and if you have questions, post your questions in the chat box in Zoom, or in the Facebook, or in the or more so in the YouTube channel, and then we will get back to you. So we will try to answer during some sessions which is scheduled in the later half of the day, but we will be happy to engage with you and interact with you to let you know what we do more. So what I propose to do is a very quick overview of the facilities at ARIES and introduction to the Abithya mission. As I mentioned, I'm a solar physicist, and I'm involved with a dedicated Indian mission called Abithya, which is expected to be launched next year, early next year. So that's a perfect demonstration of how science and technology can take India forward. So I thought I will briefly update the youngsters in this. So ARIES is an autonomous institute under DST, Government of India. Our mandate is to promote, guide, and carry out the frontline basics research in the areas of astronomy, astrophysics, and atmospheric science. So these are three, different elements, which are coupled together. So when we say astronomy, basically people talk about astronomical objects in the sky and nighttime or daytime. But then how physics can explain the behavioral change in these objects are the subject matter. And of course, we belong to Earth, and this coupling between the solar system and Earth, our sun and the Earth, is also very well studied here through our lower atmospheric sciences here. So you will have a demonstrations at the later half of the day with the balloon experiment, which regularly is done from ARIES. We would have loved to show you how the balloons are flown from here, but we have to show you some recordings. So We also build and operate state-of-the-art facilities to study the Earth's atmosphere, planets, stars, galaxies, and other celestial objects. So thankfully, we are hosting the largest, astronomical telescope from this part of the globe. Some of you are aware. And again, we'll be happy to take you a group of students to Devastal and plan for such visits also. This is my promise. So we operate these two major facilities. Devastal, of course, we have smaller telescopes as well in this campus, but these two are, I think, the state of our nation's pride. And you will go through those, later half. This is the campus where we are, and I'm giving you a lecture sitting somewhere in this block. And this is the Devastal campus. You will go through them later on. This is a close-up view of this campus where we are. Right now, I am here in this, building here in the ground floor, and all the students are living here. It's a nice, pretty place to be. I can guarantee that. Okay, so we have many students, in different levels. Why I'm just showing this, particular slide is we are a growing institute, and we are, trying to get more and more PhD students. And after you do, also you have a postdoctoral research program. So since we are addressing most of the students, please be aware that in your neighborhood, such a research institute exists. And in future, we'll be very happy to welcome you. So now let me take you to a little journey to our sun, our nearest star, which is always active. Actually, people think our sun is always there, and maybe it's just, it's a hot little ball in the sky. But actually, it's very dynamic. And as you see a little clipping here, these images are taken from a NASA satellite called SDO, Solar Dynamic Observatory. And it shows that if I take an image in extreme ultraviolet, again, astronomy is done in multiple wavelengths. I will come back to this particular aspect. All astronomical objects emit radiations in all wavelengths. And some of, I guess, high school students here are aware that, when any physical body is increased at different temperature, it starts emitting in shorter and shorter wavelengths. So these objects are very hot. This atmosphere is millions of Kelvin. The emission which is coming from this plasma is mostly in the extreme ultraviolet and X-rays. So these are images in the extreme ultraviolet. So why do we say, study sun so, such greater detail now? Because this is the closest object. The amount of details which we can study from the sun, it's not possible for other distant objects, because they are studied more as a point object, where this particular object, we can really see the details on its surface or in atmosphere and so on. So this is a correct example of that. You see, these are regions where there are strong magnetic fields, and then these, plasma is confined by the shape of these magnetic fields. But often, because of different instabilities, these magnetic fields, regions explode, and the amount of material which is confined in this, they, travel to the interplanetary space, and then eventually they reach Earth. So this is the study which we do from here as well, and Abithya mission will be dedicated for that. In the context of sun and with astrophysics, sun is a very normal star. Some of you are probably aware that any star is born from interstellar medium, and then it goes into its life cycle, and then eventually it becomes a very big red giant, and it explodes. And depending on the size of the star and the mass of the star, the final fate will be decided. Sun is a spatial star because it is the only star on which we can resolve the spatial scale on which the fundamental processes takes place. So that I have already mentioned. And these fundamental processes are different branches of physics, which we study here. Primarily, most of the state is in the plasma state. Sun is also a spatial star because it provides almost all the energy to the Earth. Our existence is because of the presence of the sun at an appropriate distance away from us, right? If sun actually decides to stop radiating tomorrow, our existence will cease within few months, actually. We can't survive here. Sun is a special star because it provides us with a unique laboratory in which to learn various branches of physics. Normally, when I give a lecture to a physics audience, because I studied physics all the way up to MSc. I never had any astronomy or astrophysics in my, up to my MSc level. I only studied physics. But then when I came to my PhD, I realized how much different branches of physics you can apply in different astrophysical scenario. And solar physics is one good example of that. That's how I chose solar physics as my subject area. Now, what I will take you through to the different layers of the atmosphere of the sun. As you know, in the Earth atmosphere also you have different layers because the density falls off as you go higher and higher heights. In any stellar environment, a similar thing happens. So when you go from the surface, what you see actually in the sky, the optical radiation which is coming with your open eyes, we can see only sense the optical wavelengths. That's called the photosphere, the visible surface. But now we have better telescopes with much better resolution, so we can see much more details as I indicated here. So here you see actually a pair of dark regions on the surface of the sun. These are called sunspots. They are highly concentrated magnetic field regions on the visible surface with certain wavelength. We have taken this image. Now, if I go about say 1,000 kilometers above the surface of the sun, this is called chromospheric layer. And if I take an image with a different wavelength, it's like wearing different glasses, and then you look at the object with the different colors. When you see with the different colors, that's how the 3D images are also reconstructed, right? You try to recompose them, and then you get a three-dimensional view. So in the stellar context also, we try to do that. We look at at different layers through different wave passband filters. So the filters like a color images, and then we try to recompose this three-dimensional picture. So this is a picture of the same region, exactly same region, about 1,000 kilometers above the sunspot. If I now go another 500 kilometers above this, earlier image what I shown, you see about, this structure is much more filamentary. It's very, very different. This image is taken from a filter called H alpha. Incidentally, this filter is there in ARIES and Nainital also. And we have been looking at the sun through this filter to study primarily flares. So flares are these huge, explosions which happens typically in these kind of regions where there is strong magnetic field. And we have been observing this for last 30 years. And some of that data we are going to make available to the public very soon. Then if I go even higher, say several 1,000 kilometers, and take an image of the same region with X-ray. So this is an image taken from, of course, a satellite. And then you see that the overall morphological structure is very different. So it is clear now that as we go upper and upper atmosphere, this magnetic field, basically it expands and it changes its behavior, and the material which is confined on those magnetic field essentially dictates what would be the the picture look like. So that was a closer view on a pair of sunspots. Sunspots are magnetic regions. They always come in pair because one has to be a north polarity or the other has to be a south polarity. You have seen from your school experiments as well. And then what we see is that if I look at it a closer, full sun view, then you will see that there are certain regions where the emission is more. The magnetic field lines are more closed. You have done this bar magnet experiment. The magnetic field lines come from the North Pole and then into the South Pole, right? So exactly that's what happens here. Whereas in the in the polar region, if I go to the polar region in the north or the south, it appears that the magnetic field lines are more open in nature. So this particular type of connectivity of the magnetic field lines actually crucially dictates how the motions of these plasma confined within this magnetic field will be, and so on. So I think I'm running a little short of time, so I will skip some of the slides. Otherwise, the other programs will get affected. This is something which I wanted to also again highlight, that modern day astronomy is done with multiple wavelength. Why? Primarily, that our atmosphere cuts off the X-rays and UVs and gamma rays and so on, thankfully. Otherwise, we would have been affected. So Earth has its own magnetic field also. So that also protects us from highly energetic particles and radiation which comes from the outer environment, and particularly from the sun in the context. So if you really want to study the any astrophysical objects for that matter today, you really have to have a combination of telescope situated in the ground and in space as well. So this is the era of multi-wavelength observation, and this is the era of real technology. And as you can imagine, that we have a 3.6 meter telescope in Devastal, which is like a 5-story building at least. with such a huge perimeter and so on, you can't get that 5-story building in space, right? In the space, there are limitations in the size and the energy budget and so on. So that actually demands, again, a different kind of technology altogether. You have to have a very compact system, which has a very sophisticated, no failure. Of course, if we launch something and if it doesn't work, you can't go there and fix it. So that means, no failure possibilities. So this combination of space technology and the ground-based telescope technology is really taking us to the next step. And that's the area, again, a lot of engineers, a lot of technical people have to contribute. In fact, today NASA is NASA simply because, if you go to the NASA, actually 80% of the scientists are engineers by profession. So they have all coming from engineering background, but they are fascinated by science. That's how they have chosen that kind of career. So I think today we are also engaging into that kind of era, and we badly demand, engineering students who are interested in science. In fact, incidentally, I would like to also mention this. ARIES is going to start a MTech PhD program. Again, this is a new avenue where the BTech engineers can come for this kind of program. 2 years they will be doing the MTech, and then they will get into a pure astrophysical, instrumentation program or a science program. So this is again a new avenues which we are now conceiving here, so that this kind of working together with the technologist and the pure, so to say, theory person to take us to the next generation. So this is again a picture which shows you a combination of optical telescope, infrared telescope. Of course, if you go to the higher mountains, this is a picture from a mountainside. Incidentally, we do have now new facilities coming up in the high up in the Himalayas, even in the Ladakh region. We are planning for setting up a new solar telescope as well there at the 4,000 meter. There you will get some infrared observations also possible. We do some infrared observations from Devastal as well. And then, of course, you have to combine with ultraviolet and X-rays and so on. So this is again a very sort of, classic example of a very close region in the sun, where we have combined, information from ground-based telescopes. So these 3 layers, as I mentioned, different layers of the solar atmosphere combined with a satellite observation. And this is a work which is led by one of my former students. But again, why I show this example is this ideal, example of people working from different parts of the globe. So Tonmay was a PhD student earlier here. And then there are people from Germany, there are people from China, and then from the US. So we need to work closely together to really be able to look at such a vast amount of data available through ground-based telescope and the space-based telescope. So that this is actually image shows that there are these magnetic field again, they move all the time, they kill each other, and when they kill each other, that produces a small kind of jets. So these are the jets. These are called spicules on the sun, and these jets produce a lot of energy, and they carry this energy to the higher atmosphere of the sun. And those jets are now considered to be responsible for heating the corona, because now we know that the corona, which is the outermost atmosphere of the sun, not the corona which we are suffering for last 1 year. Incidentally, the name of the virus has come from solar corona only. The eclipse image taken during the total solar eclipses, the solar coronal image looks like those hairy, structures. So that's actually history. And now the virus was named from the solar eclipse images as well. So that's a side story. So this is again an example of this multi-store, wavelength thing. I will quickly run through. This is the mission which I'm talking about, Abithya, which is expected to be launched next year. I'm sure that this is going to take India and the Indian solar science at least to the next phase, because there are 7 payloads on board. Payloads means 7 different instruments, which has a combination of optical and infrared and X-ray and near UV and so on. And as you can see from the logos, there are many different institutions across India. We are all responsible for supplying these instruments for this. Incidentally, ARIES will be the center for its support cell. It will be building the support cell for the Abithya mission. So all forms of Abithya data training program will be conducted by ARIES. So ARIES will host a center here, and it will have regular workshop, it will have regular seminars and training sessions to train youngsters how to use the data and then participate in the science program. So this is again a very good opportunity for our institute and people around us. We will keep track. Hopefully within a year, we'll start those training programs as well. And I would love to actually even have some small programs for even high school students as well. So I think I will skip all these details because I don't have time for this. So this is a movie of this, first movie which I have shown you. It was an explosion from these, strong active regions, the strong concentrated magnetic field concentrated regions, and that emits or dumps this amount of material into the corona. This is called coronal mass ejection. Now, sun is much away from us, so now whether these amount of material can travel all the way to the interplanetary space and eventually reach us or can hit our near Earth environment. Primarily, there are so many satellites, which can be damaged, and actually it does get damaged very, very regularly. So to study that, we have to have multiple instruments. So here actually it shows again stitching of, data taken from one particular kind of imager. Then there is a coronagraph here, which looks at some part of the some distance. Then there's another coronagraph. Then there is one heliospheric imager. Then there is another heliospheric imager. Again, to show you that how much data from different vantage points, different satellites, we have to combine to get a full understanding. It looks like there is a ejecta and then it travels all the way, but to track that ejecta all the way to Earth or beyond, or to interaction with other planets, that's again another interesting subject area which we are working on. Is it demands a lot of people, a lot of manpower. So this is the future. I thought I will just show you. So my point is, the future of solar physics or astrophysics lies with all you guys who are around, and some of you are joined, I hope, through online today. And tomorrow we would be happy to host you here. So this is a popularly known as Dipu's gang. So my short nickname is Dipu. So these are my bunch of students here, and we regularly conduct schools and workshops and so on. So that's again a picture from our recent workshop which we had in Leh. So we normally conduct schools and workshops in beautiful places. So I hope you get excited about doing things in near future. So I will stop here. See, we have not provisioned any separate question answer session now, but we have some slots in the later half. So what I will suggest is that we will collate those questions and we'll try to answer them during those intervals. But I'm always available, and I have a separate Zoom window as well for myself. So if you have questions, I can answer you through the chat box in the Zoom as well. So you can pose your questions in Zoom or in YouTube or Facebook so that I can answer it. Because there are a large number of participants joined through online, so we may not be able to answer all of it at this point of time, so that we continue with our next course of program, right? So next is the science quiz portion. So somebody has to explain this, so you will do that. Okay, so I hope you got some flavor of the kind of things which we do here. Thank you. Yeah, there are questions. How many questions are there? Okay, can you just read that out for me? Is it in the okay? Exactly are the materials given out of the plasma by the plasma of the sun? Okay, so the question is that what exactly are the materials given out by the plasma of the sun? Basically, majority of the solar atmosphere is in a very high temperature state. So when you have a very high temperature, the material is in the plasma state. Plasma means it's a collection of charged particles, neutrals, and so on. You can think it in terms of a blob of material. That's why the name plasma has come. it doesn't have any particular shape and so on. It can also realize it as a sort of fluid element. So it's a combination of different, elements. It can have hydrogen, it can have helium, and other, highly ionized particles, even iron, silicon. So it's a combination of different elements in different ionization state because of the high temperature. So these plasma will be a sort of dominated by electrons, but there are other heavy ions also embedded in this plasma. So when these plasma blob travels, if we have actually this Abithya, satellite sitting in a position called L1, we have actually 3 probes that actually going to detect these plasma blobs which it travels through, and it will tell you what is the composition of this plasma. So that's the also one of the activities which we take. Okay, I will follow the chat box and try to answer through the chat window as well. Thank you.
Thank you very much, sir, for your inaugural talk to start the session about talking about the science prospects and what kind of things could be done, and then touching upon that what sun is and why sun is important and what kind of scientific avenues do we have. So coming to the next session, because it was scheduled at 10:30. Before we hand over this session to masters, which are who are available here, Dr. Avinash and Dr. Samrat and team, I would like to little emphasize that we have 6 schools today and 6 participants, and it has been decided that in alphabetical fashion, those schools will be considered as teams. So 6 teams are there alphabetically: Birla Vidya Mandir, Don Bosco Boys, Don Bosco Girls, Parvati Prema Jagati, St. Joseph Sherwood College, number 5, and then St. Joseph's College, number 6. So these are the 6 teams, and rest of the things will be explained briefly by the quiz team, who are going to kind of announce the rules and modes and how do we proceed and so on. But just to encourage the students and let all of us know that who all are there. So from Don Bosco Girls, we have Mannat Atwal, Anni Shaurya, Salvi Gupta, Vaishnavi Khanna, Arun Veer Kaur. So let's clap for these 5 participants. Similarly, from Don Bosco Boys, we have Tanish Yadav, we have Garvit Verma, we have Amritans Vikram, Sravanya Vatsa, Jagdeep Singh, and Saurya Verma. So these are the 5 who are from Don Bosco Boys. And then we have from Birla, Vedans Goel, Jatin Kumar Gupta, Harshvardhan Singh Bist, Priyans Parsai, and Vishrut Sagar. So let us clap for those 5 who are from Birla. And then we have from St. Joseph College, we have Shrestha Sharma, Jatin Pal, Amar Ahmed, Kartiki Joshi, Parthiv Chakrabarti. So let us clap for these 5 students from St. Joseph. And then from Sherwood, for quiz session, you have Yuva Virendra, Ronit Mukherjee, Pratyush Rai, Akshat Verma, Anirudh Kanpal. So these are the 5 students from Sherwood College. And similarly, after Sherwood, we have Parvati Prema Jagati. So from Parvati Prema Jagati, we have Kushagra Singh, Ansuman Singh, Rachit, Samarth, Dipanshu, Arav, Arpan, Aryan, Avan, and Mr. Maurya. So these are 10, but out of these 10, 5 would be definitely participating in the quiz. So now for these 6 teams from 6 respective colleges, I am now going to hand over the session to the quiz masters, who will tell the rules and regulations, that how we are going to proceed and how it is going to happen. So
yeah, they're getting set up. Yeah, Parvati Prema Jagati School, I would request the people, the participants who are part of the team, to come little forward, because you are sitting too far away from the microphone. Yeah, it would be very clearly audible. You join the Zoom session? Yeah. No, we'll take that. We'll take that. Yeah, so watch out for that. The microphone. Speak a little louder. So you logged in as what? Shamrat. Where are you, Shamrat?
Yeah, this one.
Yeah, this one.
The screen.
Share screen. No, no, okay, you could share the screen, okay. हाँ स्क्रीनशॉट था
अभी मतलब ऑफ करते क्वेश्चन दिखते हैं
नहीं क्वेश्चन नहीं
दिख जाएगा साइड पे दिख रहा है साइड में दिख रहा है तो स्टार्ट तो परफेक्ट करने से बात स्टार्ट कर
यू आर लाइव हाँ
स्टार्ट तो परफेक्ट कर दो उसके बाद स्टार्ट कर साइड शो स्टार्ट तो परफेक्ट
ठीक है प्रॉब्लम
क्या करूं अच्छा स्क्रीन कहां है
ठीक है नहीं ठीक है ठीक है ठीक है आ रहा है
इधर फोन नहीं होगा वो साइड वाला विंडो डाल
वो उधर नहीं है अरे
डेस्कटॉप शेयर कर दो ये साइड पे नहीं पता साइड से जो विंडो
क्या
शेयर द डेस्कटॉप शेयर द डेस्कटॉप
उधर पिछले वाले में था हो रहा ये रहा इसका वीडियो बंद किया है क्या है ऑडिटोरियम है वीडियो नहीं है वीडियो नहीं है
can also video auditorium video not from there would go from that screen
और माइक
देख लेता हूं
अभी आई थिंक वही बना
I'll full screen now go ahead so you have to unmute it any other machine you have to mute
Yeah, can you hear me, everyone?
they are able to hear you. Go ahead.
Hello.
They are able to hear you.
Okay. So, hello everyone. Welcome to the National Science Day quiz. So, keep the name of this quiz contest. It's Quiz B. So, there will be just the rules and regulations of this quiz. So, there will be 3 rounds: round 1, round 2, and round 3. So, in each round, there will be 6 direct questions to all the schools, and there will be bonus marks. So in the first round, the first question carries the marks 20, and if the question to the direct school, if they can't give the answer or they give the wrong answer, then the question will be passes to the next team. So we'll be naming the schools in alphabetically order, team A to team F. So the first team is Don Bosco Ball. Oh, Builder. Okay. So for the team A, the first round question carries the marks 20, and then the subsequent schools, the bonus marking will be 5, and there will be no negative marking. But one thing, you have to give the answer in the first shot. If you give a wrong answer, then there will be no marking, but you can't give another attempt. Okay, so in the first round, Avinash is taking forward. Then after that,
Hello everyone. Yeah. Hello everyone.
20 seconds.
Hello everyone. Welcome to the first round of the quiz. This is the question answer round to help you get going with the quiz. And this is a straightforward question and answer round. So let's start. You will have 20 seconds to answer each question. And if you are not able to answer the question will be passed to the following team. Okay. First question goes to Birla.
No,
Oh,
this
sorry,
is a
sorry.
sample question.
Okay, this is a sample question to get you going. An experiment X was conducted in 1908, which measured the force on dash in a glass chamber sandwiched between two electrodes. With the known electric field, one could measure dash's charge. At that time, the concept of subatomic particles was not universally accepted. Identify X. Does anyone want to give a go?
Are they able to hear?
Are they able to hear
Yeah.
us?
Any of you can unmute yourself and try to
Try
answer.
to
Otherwise,
answer.
we'll not know that you are hearing.
Exactly. This is just a sample question. If anyone wants to attempt this.
Anyone from the live audience?
Anyone from the audience?
Actually, we need a response from them. We are
Yeah,
not
yeah,
sure.
Yeah, but
They can-
जावेद कर रहे हैं वो जावेद
Okay, okay.
कंट्रोलर
Unmute it now.
yeah. Shamanesh, can you confirm that you are able to hear us?
Yes, we can hear
Yes,
you.
yes, yes, sir. Yes, sir. We can hear.
Very
Yeah.
good. So the question is very hard. So that's the answer. Go ahead. That is a microphone we are using.
Somebody responded. Just call.
You're not going to the neighbor muted, I think. No.
Okay, now it's
Yeah.
okay.
Okay. Okay, let's
I think someone has attempted in
Yeah.
the chat box.
yes, so I think Samba said Madame Curie and the radium experiment. Sorry, so this is the Millikan's oil drop experiment. Okay, so let's start with the first
You
round.
have to mention the timing also.
Yeah, I think I already said that. Okay, I'll say this. So each question, you will get 20 seconds to answer. If you're not able to answer the question, the question will be passed to the following team. Okay, so let's start with the first round. And the first question goes to Birla, Team Birla. The average angular size of the sun as seen from Earth is 0.5 degree approximately. What is the average angular size of the moon as seen from Earth? Birla team, you have 20 seconds. Any guesses?
Sir, it is same. It is the same. 0.5 degree.
Okay, that's a correct answer. The team gets 20 points. Okay. Okay, so the next question goes to Team Don Bosco boys. The ozone layer lies in which atmospheric layer of the Earth? Don Bosco boys.
It is between the stratosphere.
Sir? Yeah. If the answer is correct, it is the stratosphere. Okay, so the third question goes to Team Don Bosco girls. It's evening time here. You see the sun setting in the west. You turn east and see the moon rising. What is the current phase of the moon? You have 20 seconds, Don Bosco girls. 10 seconds have passed.
Someone prompted something.
Any guesses? Okay, so 20 seconds have passed. The question will now be passed to Parvati Prerna Jayanti School.
Yeah, the participants, please switch on your videos. The teams should switch on your videos. The 6 teams are there, right? 6 teams. You have to switch on your videos. We would like to know who is answering.
Yes. Any answers? Okay, the question will now be passed to Sherwood School.
Answer is full moon.
Yeah, that's the correct answer. So this is Sherwood School, who gets 10 points for the past question. Okay. So now the fourth question to Parvati Prema Jagati School. What is the name of the first Indian satellite sent to space? You have 20 seconds. Yeah, that's the correct answer. Aryabhatta. So they get 20 points for the question. The next question goes to Sherwood School. Which is the largest moon of Mars?
So Phobos.
Yeah, that's the correct answer. And Sherwood School gets 20 points. Next question goes to St. Joseph College. Which planet has the highest average density in our solar system?
Earth.
That's a very good answer. 20 points to St. Joseph College. Okay, and there's an extra question for the audience. What is the maximum width to the Saturn ring? Anyone can give this answer. Even the people who have joined through Zoom session can take a guess at it. Anyone here? No time limit.
10 meters.
Yeah,
Approximately correct.
close.
Average.
So it's roughly around 100 meters, the maximum width to the Saturn ring. Okay. So I think scores are not. So after the end of the first round, I'll announce the scores. Birla team with 20 points, Don Bosco boys with 20 points, Don Bosco girls with 0, Parvati Prema Jagati 20, Sherwood School with 30 points, and St. Joseph College with 20 points. So for the next round, I'll hand over the system to Samrat.
Okay, so the round 2, the name is connection. So in this round, you will be given some figures. So from this figure, you have to connect the physical phenomena or the incident or what is coming into your mind. So the direct question will be 20 marks and the bonus question will be 10 marks. So for this round, we'll be starting from team B, which is
Don
team
Bosco.
B, Don Bosco. Don Bosco. Okay. So for this round, there is one sample question I want to give you. So from this figure, can you connect and identify the physical phenomena? Anyone can give the answer. There is no marks for this question. It's a sample question.
Photoelectric effect.
Yes, correct. This is photoelectric effect. Okay. So, okay, please don't write in the chat box. You can give the answer.
Yeah.
Okay.
Who answered? But how do we know who answered?
You have to ask
No,
it's correct.
that is okay.
Let them write.
That's a sample question. Okay, the first question to the Don Bosco boys for marks 20. Identify the physical principle. You have 20 seconds. Pardon? Pardon? Can you please tell it louder? Yes, correct. It's called Heisenberg uncertainty principle. So the first figure is Heisenberg and the second figure is depicting the uncertainty in position and momentum can be measured simultaneously. Okay. So the next question, direct question to team C, Don Bosco girls, 20 marks. Identify the physical phenomena. Time. 20 seconds. You have 20 seconds.
10 seconds remaining. Time's up.
Okay, time's up. Question passes
To Parvati Prema
to
Jagati.
Parvati Prema Jagati School for 10. Pardon?
Aerodynamics.
No, it's not aerodynamics. The question passes to team share root.
String theory.
Pardon?
String theory.
No, it's not string theory. Question passes
To Saint Joseph.
to Saint Joseph.
Doppler effect.
Yes, correct answer. This is Doppler effect.
Yes.
Can you explain?
Can you explain, please?
It's I mean, you got the marks.
I know, sir. We don't know the explanation for this answer.
Okay. So the first figure is showing that there is a velocity of the source where of this satellite. So actually it's a plane, not satellite. So the wavelength along the direction of the observer is increasing, and the direction from where the plane is moving is decreasing. And the second photo is a character from Big Bang Theory, Sheldon. So the wavelength of his t-shirt and the trouser is showing the Doppler shift. Okay. So the next question is to
Parvati Prema.
Parvati Prema Jagati School for points 20. Identify the physical phenomena. Pardon? Please. Ozone layer what?
Ozone depletion.
Yes, yes, correct. Excellent answer. It's the formation of ozone layer. Can you explain?
Ozone depletion.
I mean ozone hole. Formation of ozone hole.
Depletion. Actually,
Okay. Okay. Anyways, the next question is direct to share root. Identify the physical phenomena. Ten seconds remaining.
Time's
Okay,
up.
question passes to Saint Joseph.
Mirage.
No, it's not mirage. I mean, you have to tell the physical phenomena.
Reflection.
Explain the reason behind why this is.
Refraction.
Be more specific.
Be more specific. Actually, it's a bonus mark. The physical. Okay, question passes
To Birla.
to Birla.
Both. Total internal reflection.
Yes, exactly. Can you explain from the figures?
Sir, actually, sir, the heat layer is varying from the surface, because of which the refractive index of the surface is changing as we go above, because of which the light makes a
Yes.
critical angle at the base of the surface, because of which we see that there is water over there.
Yes, exactly. And the third figure is showing the optical fiber. That's a mechanism of total internal reflection. Okay.
So the question is for Birla now.
Okay. Now the direct question is to Team Birla for points 20.
Okay.
No.
This is for Saint Joseph. Sorry.
Okay, pardon. So the direct question is to Saint Joseph for points 20. Identify the physical phenomena.
Fusion.
Nuclear fusion.
Nuclear fusion.
No, we can't give you. You're close enough, but not correct.
Nuclear fission.
No, time.
Okay, time up. Question passes.
Only one guess per team.
The question passes to Team Birla.
Sir, radioactive decay.
Yes, exactly. Okay, so the first figure is showing the symbol of radioactivity. If you see the web series Dark or Chernobyl, you can find this symbol, and the second one is the radioactivity phase between alpha and beta particle. Okay, so the direct question is to
Birla.
Team Birla.
So this is the last question for this round.
Identify the physical phenomena. You have 10 seconds more. Okay, question passes. Okay, okay. Are you telling something? You can
Yes,
go for a wild guess. There is no need.
frequency.
Pardon? Okay, question passes.
Frequency, sir.
Passes to Team Don Bosco.
Don Bosco boys.
Don Bosco boys.
So it is regarding simple harmonic motion.
Yes, exactly. Correct. Okay, so can you explain the figures?
Don Bosco boys.
Can you explain the figures? What it is showing?
No, sir, not exactly.
Okay, so the first figure is the merry-go-round. It's a circular motion, so it's an example of simple harmonic motion. The second is the vibration of guitar string, and the third one is if someone is fall in the cavity of earth, so it will oscillate in a simple harmonic motion. So that's the connection. Okay, there is another question for the audience. Anyone can go. Identify the governing law of the two processes.
Wool, without wool. Electromagnetic induction.
Governing law, not the phenomena.
Faraday's law of electromagnetism.
No, it's not.
It's lenses.
Yes, it's
Faraday's
so
law.
Anjusha give the correct answer. Okay. Okay, so in the end of round 2, the score is the following. Birla is 40, Don Bosco boys 50, Don Bosco girls 0, Parvati Prema 40, Sherwood 30, and St. Joseph 30. Okay, so these are round. So for the next one, I'll hand over to Avinash.
Hello everyone. So this is round 3 and the final round of the quiz. So make sure you get as much as possible in this round. Okay, so you get 20 marks for the direct question and 10 marks for the bonus from the past question. Sorry. Okay, so this round has a specific format which is different from the other rounds. So you will be given 3 hints in each question. If you answer from the first hint itself, you will get 20. If you answer based on the second hint, you will get 15 marks. And if you answer based on the third hint, you will get 10. Okay, and any past question will only get 10 marks. Okay, so let's start with the third team of this competition.
No, there is a sample question. There is a sample question just to show you how it goes. So, okay, is the first clue.
I won Nobel Prize in Physics in 1930. Even the audience can hear.
Niels Bohr.
That's correct. Wonderful. Okay, I guess we don't need the other options.
Okay, so the next question.
Okay, let's start with the team C, which is Don Bosco girls, with a direct question. The first hint is I went to space by Sputnik 2 spacecraft.
20 seconds for each hint.
So you will be given 20 seconds for each hint.
You can opt for the second one.
If you're unable to answer, you can tell me and I can give you the second hint. Because if you take an attempt, I will have to pass the question. Okay, so time's up. I'll give you the second hint.
Hey, passes, question passes.
No. Second hint. I belong to the Soviet Union. Any guesses? Or do you guys want the third hint? 5 seconds more. Okay, so time's up. I'll show you the third hint. I'm a dog.
Sir Laika.
Yes, that's the correct answer. So Don Bosco girls get 10 points. So next question goes to Parvati Prema Jagati School. The first hint is, I'm a cosmonaut who went to space in 1984 at the age of 35. You have 20 seconds. Okay, so time's up. We'll show you the second hint. I joined Hindustan Aeronautics Limited, HAL, in 1987 as a chief test pilot. Yeah, that's correct. Brilliant answer. Parvati Prema Jagati gets 15 points. So, next question goes to Sherwood School. And the first hint is, I'm a spacecraft which was launched on 22nd of October 2008.
Sir Chandrayaan 1.
Oh, that's a brilliant answer. That's correct. Sherwood School gets 20 points.
Now St. Joseph.
The next question goes to St. Joseph College. I said, you adjust your intelligence in the weightlessness of space. Who said this famous quote? 20 seconds. Okay, so time's up. Second hint. I flew in this space shuttle Columbia in 1997.
Kalpana Chawla.
That's correct. St. Joseph College gets 15 points. The next direct question goes to Birla School. This figure is named after me. Who am I referring to?
Sir Penrose Triangle.
Yeah. No. So who is the person?
Sir Robert.
Yeah. He said that. Okay. So that's correct. Roger Penrose. So Birla School gets 20 points.
Can you explain? You can explain the triangle. But
He said it. So the next direct question goes to Don Bosco Boys. I derived the identity 1 plus 2 plus 3 plus till infinity equal to minus 1 by 12.
Ramanujan.
Yeah, that's correct. Don Bosco Boys get 20 points.
So
The round is over. We'll announce the results shortly. Now there's a question for the audience. I was in charge of the secret weapons laboratory of the Manhattan Project. Okay.
Okay, so,
famous way times.
okay, now Ankur will announce the score.
okay. So after the third round, Birla School got 60 points. Don Bosco Boys has 70 points. Don Bosco Girls with 10 points. Parvati Prema Jagati with 55 points. Sherwood College with 50 points. And St. Joseph with 45 points. So the winner of this quiz contest is Don Bosco Boys with 70 points. Second is Birla School with 60 points. And the third is Parvati Prema Jagati with 55 points. Okay, thank you all.
Thank you all.
Yes, thank you very much for all the teams to participate very actively and overwhelmingly responses by all of them. Few questions which were directly answered by few of the teams were really fantastic, and was in some sense it was unexpected also. Unexpectedly, the responses were very good. So it means all 6 teams are really preparing very well. And I would also like to take this opportunity to ARIES team of Samrat, Avinash, Ankur and others to host this quiz session very, very nicely. So thanks all. And I think it's the first, second, third names have been announced, but as they show that all participants were really actively participated. And I would say all of them are winners. And so as promised, ARIES would shortly issue certificates to respective teams. And thanks again. So now we are coming to the next round of this first half of the session, where we are going to have a short talk.
Excuse me, sir.
Yeah.
This is Harvard College. We got 50 points overall, so we should come second, I guess.
Second was 60. Second was 60.
Then,
The second
then
was
third, 50 points. Then third with 50 points.
no, Parvati
55.
Prema Jagati with 55 points total.
55.
Yes.
Thank you, sir.
Okay.
You're very close, don't worry. You know, we are all good. I mean, it's what is important is participating in. You know, it's very nice. Yeah.
Yeah. So who was the first then?
The first was Don Bosco Boys with 70 points.
Right. Second.
Second is Birla School with 60 points. And third is Parvati Prema Jagati with 55 points.
And then of course Sherwood.
Yeah, Sherwood with 50
Yeah,
points.
yeah. No, no. I would say that at this point of time, not only Sherwood, even Don Bosco girls and everybody participated well. So as we said that everybody is there on the equal footing. It's just a matter that in those 20 seconds, who was little more, the responses were better. It doesn't mean that students who scored rather less marks are not that bright and enthusiastic. So on behalf of ARIES, we are really considering all the participants, students on the equal footing. Everybody is equally good, competitive, and we all are wishing our level best for their future endeavors. In other opportunities, I would believe that other teams would respond and would perform better. Thanks. मैंने talk इसमें है कैसे आंसर हुआ I think it's in here desktop.
Let's go back. Where is the machine here?
So now the second, the third program of this session would be the telescope making. So I myself is going to speak about telescope making. So please, I would request participants to just listen to talk, and later on we would go for question answer session. मुझको देख रहा है
इसके सामने होल्ड कीजिए, ये वाले के सामने होल्ड कीजिए, ये वाला हमेशा
हाँ this is it. देख लो ना, ये थोड़ा सा डार्क है ऊपर का ना,
बट स्क्रीन शेयर है तो you don't need to actually ना।
नहीं वो उधर का सर्कल।
अच्छा ये देखो मैं यहाँ पर हूँ।
ठीक है।
Yeah, so thank you very much, and I welcome all the participants again to the next session that we have, the telescope making session. So in this session, first we are going to talk about what telescope is, and how does the telescope look like, and what kind of telescopes do we have, and internationally what kind of telescopes are we using, and so on. So with this note, I would. Yeah, so I would say that theme of the National Science Day 2021 is Future of STI, Impacts on Education, Skills and Works. So as I explained, that science, technology, innovation is basically to use that how exactly we are going to use them for education, skills and work. So since high school intermediate students, you all are in education as a part of education. So for you, it's very important to understand that how important it is for us to know. So just by taking example of a telescope, as I believe that high school intermediate students are there, so they know the refraction and reflection. So these are the two basic phenomena which are important to understand the telescope. So what is a telescope? It's an arrangement of lenses or mirrors or both to gather light and bring it to the focal point where the radiation is analyzed using different kind of instruments. So the primary purpose of astronomical telescope is to provide focused light. It could be spectra, it could be image. So reflecting and refracting are the two kind of telescopes that primarily we have. And as you all are aware, that the telescope in which light from an object is gathered and focused by lenses with resulting image magnified by the eyepiece is the reflecting telescope. So as you can see that a candle here and how with a converging lens, the light which is coming passing through the central axis is passing directly because acting like a plain glass plate. But due to this curvature, the light bending phenomena is allowing us to have an image. So depending on that from this convex lens, where the object is sitting, that is within focus or at a focus twice of the focal distance or in between and so on, you get an inverted image. So that's the first principle. That's how the telescopes works. And a lens bends the light as it passes. I explained you. And the internal structure is something like this. So as you can see, that if you have a lens in here and incoming light is falling, then it will get focused to a focal point and then again it will start diverging. So what we do, that you use another set of lens or lenses and try to make sure that through eyes, you are able to see it here. So depending on the property of this lens, the magnification, how faint or how better you would be able to resolve the sources is defined by this particular lens. And once you put these two simple optics to a great accuracy, that is at optical accuracy, then external look of a typical telescope that is refracting would something like this. Similarly, what is the drawback of a refracting telescope is following. The chromatic aberration, not high school, but those of you who are in intermediate may understand that when light is reflected through gross, shorter wavelengths bend more than the longer wavelengths, and that's how different wavelengths are focused at different points. So these are the reasons that once you use a very big lens, you will get this kind of problem. This could also be minimized by having group of lenses and a chromatic lens if you are aware about the terminology. I'm sure you are. And that's how we decide that to have a better and bigger things. What are the problems? That the peripheral support, because the lens has to be clear aperture. So the peripheral support can only be provided. Designs are very bulky, difficult to use for photography, and cost is also become very high once you use bigger and bigger lenses. So that's how there is another, yeah, before I go, here is the most famous refractor of this world. That's the Galileo's telescope in Florence, having 2-inch diameter. And the largest we could reach is this. There's the Yerkes Observatory, Wisconsin, That's the largest refractor, have a diameter of 40 inches, that is 102 centimeters. But later when people realized that if you want to go for a bigger and bigger telescope, then you have to use another phenomena called reflection. So that also works equally good. And telescopes in which light from an object is gathered and focused by a concave mirror, as you can see. So light is falling and an concave mirror, because it's a curved surface, so it will definitely be focused at the point like with the lens. And then you can have your instrument here and you can have an image. And as you can see that contrary to a lens, this full back portion is there to support. So you can have a larger and larger telescope. So that's how reflectors are preferred better than refractors once it comes to at least optical telescopes. Concave mirror reflects the light, and that's how we gather. And the internal design, as you can see, that whether it's a refractor or it's a reflector, with a combination of two lenses or with a combination of two mirrors, it is always possible to make an eyepiece. And if you don't have an eyepiece, then in place of eyepiece, you can put some instrument through which you can analyze the gathered photons. So that's how a reflecting and refracting telescope works. And these are the other typical external look of a typical telescope is. And at this point of time, I would like to demonstrate you here that here is a telescope, very small telescope. And as you can see that here is the objective lens, and then here is an eyepiece. So in hands, I have a very small telescope, and this telescope is 50 millimeter, that is 5 centimeters diameter objective, and the light is passing through here. And if you have another set of lens which you can use as an eyepiece, so depending on the focal length combination and diameters, you can decide that how your telescope will work. And it's very simple to build a telescope like this. You can build it at your home or in your laboratory. So there are a couple of phenomena which I will touch upon. That here is the, before I go, here is another Newtonian focus. That is, you can use a third mirror and you can build something like that. Light will again reflect, and a person sitting or an instrument sitting could see. That is known as Newtonian reflector. It is also possible Spitz-Cassegrain, where the light is falling to the secondary, and through secondary you can have a primary hole, a hole in the primary mirror, and then also it is possible to see. That is known as Schmidt-Cassegrain. And the most important thing for you, the take-home message, is that aperture, that is objective, that's the diameter, size of the first concave mirror or lens, where light gets reflected or refracted, is known as objective size of the telescope. And this defines the size of the telescope. Once we say 1 meter telescope or 3.6 meter telescope, it means we are talking about the primary mirror or the primary lens of the telescope. And the light gathering power, as you can see, the area of objective and area of pupil, I'm sure you must have heard, so I will not take much of your time and proceed ahead. Second important quantity after diameter is the focal length. The distance of a reflective lens or a reflective mirror takes for the light to come to the focus is known as focal length of the objective. So the focal length could be shorter or longer depending on the size and aperture, radius of curvature of the lens or the mirror which you are using. And that governs that where the image is finally going to be focused. So if this distance is larger, it means your telescope's apparent size would be larger. In this case, it could be smaller. Second important quantity that is important for you to know is the F ratio. F ratio of a telescope is determined by dividing the focal length of the primary lens
or mirror by the aperture size. So lower the f ratio, faster is the telescope is, and so on. So the f ratio, just by taking the combination of the focal length and the aperture, it could be decided that what is the field of view of a telescope, or how faint or bright the sources you are going to see. So these are the two basic parameters which astronomers usually take care while deciding about a telescope. All right, here are the, I would like to little take of the time before I converse my talk to tell you that here is the Hawaii Islands in US, then in Chile, then in La Palma, then in Russia, then in Australia. That's where major telescopes for astronomy purposes, both in southern hemisphere as well as in northern hemisphere. You have observational facilities in optical and infrared bands. And India, as you can see, in a very, very crucial place where you have from Australia to Canary Islands, you have around 12 hours longitudinal gap. So having telescope right here is extremely important. And that's how in India, we have several observatories around. In Kavalur, 2 meter, 2.34 meter, in Hyderabad, in Pune, in Guru Shikhar, in Hanle, and in Nainital. We are sitting right here. We have a couple of telescopes here. As we all were told by our director, Professor Dipankar Banerjee in the morning, that in Manora Peak, we are sitting right here, and in Devastal. That's the 3.6 meter, India's largest optical telescope is available. And as said by Director ARIES, with a given opportunity, you all will be given a chance in case if you want to have a tour with the COVID restrictions off. So that's a 3.6 meter telescope with a close-up view. You can see it's a 30 meter height, 500 tons building equipped with several important things which are very much necessary to have an optical telescope functioning at an international standard. And if you see the inside view of a telescope, this is around 6 feet. So you can have this large structure, half a degree science field of view, a large reflector. We are saying that it's a large reflector because it works on the reflection basis concept. And here is the primary mirror, and you have secondary somewhere here. So light is falling on the primary, reflecting back to secondary and coming back to this yellow point where you can have your instruments to mount and see. And couple of more, I will simply flash the telescopes around. That's the largest area used. In Canary Islands in Spain, you have diameter 10.4 meters. So you can imagine we have 3.6 meter and 10 meter. So it means 3 times larger diameter. And if you convert into area, it will be multifold. So it means more faint objects and more farther you will be able to see once you increase the diameter. Here is another kind of telescopes, large telescopes in the world. There's a Ket Twin Telescope. So 10 meter diameter, 2 telescopes are there in Hawaii. They are used for frontline sciences. And here is in Chile, the European facilities are there. 8.2 meter, 4 units. And as you can see, that they have been designed and put in a very special fashion. And if necessary, combination of them and their distances decide that very special efforts like interferometry could also be done. And you might have used binoculars in your home. And here is the world's largest binocular. So the binocular which you might be using maybe 5 centimeter to 10 centimeter diameter each. But here we are talking about 8.4 meter diameter, 2 telescopes sitting together. And that can also act like a telescope. And our director, in his remarks in the beginning, he also mentioned about this Kitt Peak, USA, the largest solar observatory of the world so far. We are planning even better and even bigger, but at the moment, that's how a telescope can also be designed, and it could look like this. So depending on what you want to do, how do you want to proceed, different kind of designs are obvious. And here is in South Africa, you have another telescope that's the largest mirror dimension. That's also functional. And if you want to construct a telescope, then you choose a site, something like this, as you can see, no light pollution, nothing. Then the top, you reach there somehow, cut it, make it flat, and make sure that you have very big, large facilities to do all these. Then you have boom cranes and so on to erect the building, something like that, and something like that. So that's the house of the telescope, and you complete it, and then you place your telescope inside. And here is another telescope which is planned, and India is very much partnering to this telescope. The name itself signifies that's 30-meter telescope. It means the diameter of the primary is not 5 centimeter or 1 meter. It is going to be 30 meters. So that's the world's largest optical telescope, one of the largest world telescope. And even bigger telescopes are also planned, but 30 meters itself is a very big facility. Even bigger facility is also planned by Europeans, and that is known as European Extremely Large Telescope. So you can see people are standing right here, or a car, and the diameter of this telescope will not be 30 meters, but maybe around 40 meters. So, and if you place a jumbo jet in comparison to the big building where this telescope is going to be housed, the comparison is something like this. All right. And then we all are aware that what the Hubble Space Telescope is. Through rockets also, you can launch a telescope in lower Earth orbits, and Hubble was launched long back, and a diameter of only 2.3 meters. And now a successor called JWST, James Webb Space Telescope, will be launched soon. The diameter is going to be 6 meters in space. All right, since this, I will take a minute, since this theme of this year is STI and how to use for impacts on education, skills, and work. So since you are having an education and you are going to develop some skills, and later on you have to work, so it fits very well. And if you want to understand universe and understanding laws of physics by understanding cosmic bodies like cosmology, large scale structures, galaxies, agents, black hole, stellar physics, exoplanets, solar physics, as mentioned by our director, planetary systems, gravitational waves, and want to be a professional astronomer, then don't miss making and building a very good concept about physics and laws, mathematics, electronics, computer programming. Once you do all these, then you can either go to the observational astronomy and astrophysics, that is observing celestial objects, analyzing data, catalogs, interpretation, the information in terms of physics, theoretical astronomy and astrophysics, that's doing mathematical modeling, simulations, coding, and understanding physics in terms of mathematics. Astronomy, instrumentation, design, and development is another very emerging area where a lot of people are required. Development of detectors, telescope making, control systems, software, and communication, and so on. And if you do and plan something like that, and you are somewhere here, if you go from here to maybe here or here, depending on how do you plan and what do you want to do, then you will land up doing your master's at some stage, either MTech or MSc. After that, you have to do PhD in astronomy and physics or something like that, followed by maybe some postdoctoral experiences and so on. And once you have that, then faculty positions in different research institutes and universities, national and international observatories. It's also possible to have placement in industry, software companies, and planetariums, etc. So that's how astronomy could help you. Thank you very much.
Thank you,
So now-
Shashi, for the talk. Now you continue with the remaining part.
Yeah, so thank you very much. So thanks students for having a lot of patience to listen me and previously to all our sessions. And now we are open. The time is little less. So as mentioned by our director, that few of us are available here in this room to answer you. And some of you will be entertained with a given limited time. And those who are not getting time or understand that if they can write their questions in respective chat boxes of YouTube, Facebook, and Zoom, then also you will be answered.
Yeah.
So please ask questions.
Yeah. So I can just indicate that in your Zoom session, you will see in the lowest panel, you have a option of raising hands. So this comes under the reactions icon. You will find an icon called reactions at the bottom panel. And there you will find an option of raise hand. So if you raise your hand, then we will be able to, identify who has the question at what sequence, so that, we can place them in order. So please use that option of raise hands.
Connectivity
Yeah,
maybe somebody has answered, then I again need to take some backup slides or something. So you can minimize it.
I think there are some questions already.
Chat mein?
Students, you are encouraged to ask questions. Please do so.
So there are some questions.
Respective teachers are requested to please encourage them to ask questions.
So there is a question from Ronak Agarwal. If we want to buy a telescope as a beginner, so can you tell us that which type of telescope we should buy, refracting or reflecting?
Yeah, so reflecting or refracting telescopes, I mean, both models are available depending on what do you want to do with that telescope and how much budget do you have. It's a combination primarily of both these information. If you want to do and address something specific, some science question which you have in mind, so then you could go for, then you can better decide. But if you don't have that option, and if you just want to use it an amateur astronomer and just to want to see celestial objects and so on, then any one of these two would be better. But primarily in the market, getting refracting telescopes, for the reason I mentioned, is little hard. Even smaller telescopes are available for in refraction modes. So I would say that for all practical purposes, you go for a refracting telescope. Also, yeah, reflecting telescope.
Yeah, so the second question is from Zia S. Burles, Sherwood College. What are AGNs?
AGNs, yeah. So AGN, it's an abbreviation for active galactic nuclei. So, galaxies are very large structures having billions of stars into it. So AGNs, by name at it signifies it's an active galaxy. Active galaxy means those galaxies where star formation process and activities are much higher than normal galaxies like our Milky Way.
Okay, so I see a raised hand from Parvati School, Jagriti School. Can you unmute yourself and ask your question now? There are other questions from the chat box I will get back to, but Parvati, School, please go ahead.
My question is regarding the nuclear fusion occurring in Sun. Sir, there is no pressure and no temperature compatible for the nuclear fusion. How does hydrogen react? Hydrogen combined with hydrogen to form helium.
So we couldn't, hear you very clearly, but I understand your question is about the nuclear reaction which is happening inside the sun, right? So is it that, you have a doubt that how is it possible that the, nuclear reactions are happening?
Yes, sir. My doubt is that there is no temperature and no pressure regarding the nuclear fusion.
Okay. No, you're actually, confusion is there. So basically, at the core of the sun or any other stars, the density is very high, very high. So there is a reaction called PP chain reaction, which converts hydrogen to helium. So nuclear reactions does take place because of the very high density. So, that triggers, and the temperature is actually tens of millions of Kelvin. So it's a very high temperature, high dense, concentrated region, which triggers the fusion reaction. Normally, fission reaction starts at much lower temperature, but for fusion to happen, you really need very high density, and it does exist at the core of the sun. And once these, hydrogen get exhausted, then, some other reactions takes over for supplying the energy for a star. But for a sun-like star, it is the PP chain reaction which converts hydrogen to helium.
One more query, that what happens when Big Bang occurs? When Big Bang occurs, there was not such density. Then how does the nuclear fusion started when the Big Bang occurred?
Oh, no, you are actually completely at a different scale. You see, Big Bang is considered to be related with the start of the universe. So there, the environment or the conditions are very, very different than what we are talking about. Any nuclear reaction starting from a star. What happens in a stellar context is the interstellar medium, it starts collapsing. So when you have some interstellar medium material slowly coming together, it collapses, and then when the density crosses a critical height, then only nuclear reactions starts. So very broadly, one can actually differentiate between a star and a planet by that, because in the planets you don't have the nuclear reactions in the core. Okay, so you need such high densities from ISM. Okay, so there is a chat box question from, okay, I will go one by one. Can plasma be created with electricity? Question is not really posed, probably completely, but what I understand is how to create a plasma in a laboratory environment, if you say so. In a way, you are right. So you really need a very high voltage environment and currents, so that the material has to be taken to the plasma state. As I indicated, normally you have solids, liquids, and gas, right? These are the three states of matter which you are familiar with. Once you have a gas somewhere, and if you subject it to it with a very high currents through electricity, of course, then that particular gas material will start getting charged. So you will have a combination of charged particles and neutrals and so on, and that state is called plasma. So you are in a way right. In a laboratory environment, with using electricity, you can produce a plasma. That's how the plasma, tubes and plasma confined regions called tokamaks and all that are made in the laboratories. Okay. There is a question from Vidya Mandir. How is a collection of stars considered to be a constellation? So these are for you, Shashi, please.
Sorry.
How is a collection of stars considered to be a constellation?
Okay, so constellation from Birla Vidya Mandir, as you can see, that actually whatever stars you see in the sky, they are all part of our Milky Way galaxy. Probably maybe 10 to 11 stars. Some of them are very bright, and they're so bright, and actually what you are able to see up in the sky is actually a 3D space and time. So in space, that 3D structure from Earth, we are able to see just the projection of all those things. Maybe in a celestial sphere kind of thing, if you can imagine. And then whatever stars you are seeing in the 3D space, actually at various distances and at various brightnesses. But some of them, apparently, they look like in a certain structure, especially the brightest ones. So long back, when we did not have enough knowledge and idea that actually what this 3D space is and what is the real distance of stars and brightness, then to understand space, actually we identified certain structures, and then we got, let us say, Saptarishi Mandal, Ursha Major, where 7 stars are supposed to be lined up around polar star, and they are moving, and several similarly other several constellations. So in this process, total 88 constellations were identified in the sky. Actually, they don't have any physical significance, but just to spot and identify a certain part of space, we had that concept, and still we have those concepts. If you want to really visually identify some part of sky, then constellation helps.
Okay, so I think we'll also try to look at questions in the YouTube channel as well. So I will try request Anku to pronounce some questions on YouTube.
The first question is by some 3453. I don't know the name. So the question is, how can we formulate the Doppler effect of light purely in terms of the curvature of the space-time in the region? Okay.
Would you like to explain?
So Samrat?
Yeah. So we will, have some our senior students also to participate, so that you get a perspective as well. Yeah. Go ahead, Samrat.
Okay, so the Doppler effect is basically when the source, and there is a relative velocity between the source of the wave and the observer. But in terms of the question was exactly in terms of the curvature of the space-time. Actually, in the case for the galactical body, there is also called the red shift and the blue shift. If astronomical object is coming towards you, so you can see the wavelength in the blue region. So that's why you get the blue shift. But if it is going away from the observer, so you'll get the red shift. That's why we can see, we can infer the expansion of our universe because it is shown as a red shift. So from there we can infer the Doppler effect in terms of the cosmological and the curvature of space-time.
There is another question which is also trying to explain the same thing. What do you mean by the universe is expanding, and what is the evidence to prove it?
Yeah, so that's what I just explained.
So the another question, why rainbow is curved?
One more line. This is students should know. What evidence? What evidence?
Yes, what evidence?
Yeah. So in terms of evidence, like Dr. Samrat just mentioned about blue shift and red shift. So evidences which we have seen so far is taking a spectra of different galaxies. So wherever we have seen those spectra, all galaxies seems to have just red shifts. So that clearly indicates that actually the universe is expanding. So that's a very strong piece of information. And that's how probably we believe that it is an expanding universe in space-time, because all galaxies are showing only red shift. Some millions of galaxies, none of them have yet shown any kind of features which is related with blue shift. So it is related to the previous question, in fact, that in the space-time things, the Doppler effect is in fact, Doppler effect in light is in fact seen in terms of expanding universe.
Just to add to Sir's points, you can just imagine a thought-based experiment. You just put some dots in a balloon and then you blow the balloon. So when the balloon is blowing up, so the intermediate distance between the dots will increase. So that is exactly happening. So that is exactly happening in the case of universe.
Okay. So the next question is from the YouTube by G Yogesh, that why rainbow is curved.
That's a very good question, Yogesh. So I would like to state that this basic principle of why a rainbow is curved lies behind how a rainbow forms. So rainbow is basically refraction of the light which is coming from the sun through water droplets which are there in the suspended sky. Okay, so this refraction happens at an angle of 140 degrees. After multiple refractions, the light from the sun enters the droplet, gets refracted by 140 degrees and reaches the observer. So if you see any rainbow, it is always formed in the opposite direction of the sun. So if I have the sun which is facing the direction towards my right, the rainbow will always be formed towards my left. Okay, so but then if I have to form a rainbow, as I stated earlier, the angle of refraction is of 140 degrees. So for me to form that rainbow here, I have to have a semicircular cone which faces the direction opposite to the sun, and only those droplets in the sky can actually make a rainbow because of the effect which reaches the observer eventually. So the underlying principle behind the rainbow being curved is because we need the refraction at 140 degrees to reach the observer's eyes, and that will make a rainbow appear curved. Okay, thank you.
Now, the next question by someone is, why isn't there any internationally collaborated interference telescope along the coast or of the various countries or amongst the islands clusters working in the same principle as the radio telescope like GMRT?
Yeah, so like GMRT, recently you might have heard about discovering the black hole using event horizon telescopes. So in case of radio, it is possible, but in case of optical, establishing the facility or having a telescope is quite tricky. So like in case of radio telescope, you have to have a large place where you don't get radio interference and so on at the neighboring frequencies. Similarly, in case of optical, you have to have a site search where you get a very dark skies and very kind of seeing one terminology where you are able to see a very stable sky and with temperature interferences and are not there, and you get a very stable and dark skies for a very long time. So that's always not possible to get on all possible coasts. Otherwise, you are right that in principle, it is always correct to say that increasing baselines in case of optical could also be done by establishing telescope. Wherever we get the largest baseline, that may be always possible, but getting a place to invest that amount of money and having an optical telescope is always not that possible. So a lot of other limitations are there, because of which in case of optical, we don't enjoy that point.
Okay, we'll take now some questions from the Zoom session. There is one question from Mr. Pradeep Chakravarti. Are there any scope for the working personnel working with engineering wing with ARIES to pursue master's degree in engineering, as mentioned by the Director ARIES during the inaugural speech? See, all the master's program, whether it is MTech program or or a MSc program, is governed by the university regulations. So the universities demand certain criteria for selection. So it could be a test, a written test, followed by an interview and so on. So there are certain national level tests also, like GATE or JEST or CSIR NET exam. So any student have to come through some national level entrance exam, followed by an interview which happens in ARIES. So for both these programs, we will be following same principles, because ARIES cannot give a degree. So eventually we are associated with a university. So the university's regulations we have to follow. So that's the system which we follow here. Next question is from Ronak Agarwal from Sherwood. How was the Milky Way galaxy discovered, and how did we got to know that there are many galaxies in the universe?
All right. So very nice question. And Ronak, initially there was no idea. For example, if you are sitting inside your home and if you want to know the full structure of your building, so that is not possible for you to see unless you come out of the building and go to a certain distance from where you can have the full look of the building, that how does it look like. Or for that matter, if you want to see full view of Nainital lake, then from your home probably you cannot see, but if you go to China Peak or somewhere snow view area, you will be able to see the full view. So since we are very much part of Milky Way, and it is not possible to go at the moment beyond our solar system even today, so people took some indirect methods, because initially it was an astronomer called William Herschel, the very first, who mapped nearby stars and tried to understand that how our Milky Way should look like. So he produced something not far away, maybe some 100 years back or something. But in last 50 years, we developed many new techniques using refractors and reflectors in optical and infrared, and we mapped the sky throughout. And after mapping, we now know very well that our Milky Way has 10 to the power 11 stars, estimated theoretically still, but millions and millions of stars are identified, and they were seen to be formed in spiral structures. That's how our Milky Way is known as a spiral galaxy. And similarly, with advanced techniques, we also identified that similar spiral structures and elliptical structures are also spread out throughout with a term you just heard, redshifts. At various redshifts, we identified different kind of galaxies throughout, and some of those galaxies were also found to be clustered, that is cluster of galaxies, and that's how we got large scale structure. So there is no doubt accepting now that it's all large scale structure. Galaxy clusters are the building blocks, and galaxies and galaxies and galaxies are there throughout, and our Milky Way and nearest neighboring galaxy Andromeda are also kind of galaxies which are very nearby. But in far away, wherever we see using our large 10-meter class telescopes, what you just saw, we just see galaxies and galaxies. So it's a pretty established fact that galaxies are there.
Next question is from Don Bosco Girls College. How do we determine the age of the universe?
Yeah, age of the universe is a first of all, it's a theoretical thing. Observationally also, wherever using different kind of techniques we have, and using those techniques, we can say something about the age of the universe. So we don't have any direct way to estimate, but using several indirect estimates. For example, age of sun. Let's say sun's mass is around 10 to the power 33 grams. And whatever energy is coming out per second, now we know very well that around 10 to the power 16 gram hydrogen is getting fused per second. So if you divide 10 to the power 33 by 10 to the power 16, then that's the kind of rough order which you can have in case of sun. Similarly, in case of other stars also, we have means and ways to determine age. And that's how we land up somewhere close to what we call 13.8 giga years. Yeah, is the kind of theoretically estimated age, but we don't have any direct evidence yet to measure that. But with ways and means of estimating age by various other objects like galaxies and stars, we have some way to say that this is the kind of order where we get. Another is the carbon age technique, carbon dating, and so on, fossils and other things on Earth where we have some sort of age determination.
Okay, we'll take the next question, which is a very thoughtful question from Yuva Virendra from Sherwood. Sir, what are your thoughts about the existence of multiverse, parallel universe, and an alternate reality? So these are, to some extent, we can answer physics-wise, some probably more philosophically. So I would request one of our students to answer that.
So that's very interesting question from like popular science point of view. So in reality, what our observations and experiments are concerned, so we do not have enough means we do not have any evidence that there is a multiverse or parallel verse. Though in theory there are some string theory and others which establish these kinds of concepts, but in science fiction TV shows and movies you do see this, but in real physics and science we do not have any observation that such a parallel universe or alternate reality exists. So we don't know at present.
Thanks, Ritesh. So next question is from Raghuvansh Singh from Sherwood again. The question is, can a black hole suck in another black hole, provided that both have equal force of gravity?
Yeah.
So I mean, fantastic hypothetical and thought-provoking questions. So I will ask again another student to answer.
Raghuvansh, this is a very good question. So I would like to inform you that black holes interact quite often. So a black hole can indeed suck a black hole, and basically they can merge into a. So this kind of event is known as black hole merger. And what happens is that a large amount of radiation and sometimes gravitational waves are also launched in this kind of event. So if you follow the news, a few years back there was this gravitational wave detected. So this detection came from a binary black hole merger. And also sometimes we have gamma ray bursts. These gamma ray bursts are also emitted from these black hole mergers. So we monitor them using our ARIES facility as well. So yeah, it is possible, and it happens quite often.
Good, thanks, Vivek. So the next question is from Vidya Mandir. What will happen when Milky Way and Andromeda will collide?
Yeah, so Milky Way is the galaxy where we live, and Andromeda is the nearest neighboring galaxy, that is M31, and that is also a spiral in nature, as I was saying a few minutes back. So yes, it is very much speculated that at some point of time, these two galaxies will collide. And this kind of colliding galaxy structures have observed. Some hundreds of such structures have really been observed where two galaxies are colliding. You can see them colliding. But what will happen around 40 million years after, that at some stage our Milky Way and Andromeda will collide. And after colliding, a new galaxy will be formed. So after colliding, maybe a new galaxy structure will be formed, and that will be spiral or maybe later on, maybe elliptical in nature. And such kind of systems have been observed. And in case of Milky Way and Andromeda also, it is speculated that they will collide and they will either form a spiral or later on an elliptical galaxy.
Okay, so the next question is from Don Bosco School. What exactly the geotail is? So I will request Viren to answer that.
Okay, so I will answer this in two ways. So the first short answer about geotail is it's actually a satellite, I think a Japanese satellite, which has been launched to study the Earth's magnetosphere, particularly the tail side or night side of the magnetosphere. Now, so answer the second answer, and probably what you wanted to ask was, what is the magnetotail or magnetosphere? So basically, the Earth has a magnetic field. Now, if you see the magnetic field, or if you pour iron fillings around a bar magnet, you see these magnetic field lines, which are pretty symmetric. So it is called a dipolar field. Now, if you see the Earth's magnetic field, and if you go slightly away from the Earth, so you will see the Earth's magnetic field is dipolar. But you go far away from the Earth, then you will see that the magnetic field of the Earth is not dipolar anymore. On the day side, it is compressed, but on the night side, it is very much elongated like a tail. Okay, so that region is called as magnetotail, and this satellite geotail has been launched, and it is going to study that part of the magnetosphere of the Earth. And this magnetosphere, it's a long oblate kind of protective cavity, you can say, which is protecting the Earth and obviously us from the harmful radiations and solar wind that is coming from the sun.
Thank you, Viren. The next question is from Birla Vidyamandir, Nainital. What are your thoughts about quantum tunneling? So who will answer the question? Samrat is coming to attempt that.
Okay.
Tunnel you through.
Okay, it's basically a textbook question. So in quantum tunneling, basically what happens? So first, let me tell what happens in the classical scenario. In classical physics, like if you have a potential barrier and your energy is less than that barrier, then you can't cross that barrier. But what happens in quantum mechanics? So if you have a potential barrier which is more than your potential energy, then there is some probability that you can just cross that barrier. But why this happens? No one knows the answer. Because as in the quantum mechanics, there is, if you have that, if you know that it is called the wave function. So from wave function, you can calculate there is a certain probability. Actually, I think in class 2, you don't know that equation. This is called Schrodinger equation. If you solve that equation, you'll find a probability that there is a chance to cross that barrier. But as the Feynman said, no one understands quantum mechanics. So that's why, so you also don't know why it is happening. But mathematically, you can prove that there is a probability.
Even in case of sun, you can find the quantum tunneling.
Yeah, that actually happens in physics also, in like physical scenario also. Yeah, there is a probability, but intuitively you can't find it. It's a mathematical solution.
Okay, thanks, Shamrat. The next question is from again Ronak from Sherwood. Nice to see Ronak being quite active. The question is universe flat or just like Earth, that we will come back to a place back if we start from one place in the universe?
Yeah, so universe actually
as I mentioned in the very beginning, that our whole history behind understanding the universe, even if we take Galileo's telescope era, that is 400 years, and as I said, that sun's lifetime is of the order of 10 to the power 11 years, or something like that. So if you see that order, then our whole knowledge about things are not very vast, and on time scales it's very limited, right? So I forgot his question.
Yeah. Is the universe flat?
Yes. So
or just like art?
Yeah. So
then we will come back to the same place if we start from the same.
Why I was saying that it's just 400 years is that 400 years is definitely a very less time scale, and out of that last 100 years where we have really got observational things and some physics behind it is even less. So theoretically, it has been conceptualized and formulated and worked out that the universe, we thought that it could be a static universe. Then we say that it's maybe an oscillating universe. Then we also know that it is an expanding universe. And as we just pointed out, that observationally evidence-based things, if we say it, and wherever we saw, all galaxies are just going away from us. That is redshift, and redshift. So about static universe, or for that matter, oscillating, and if in case of oscillating is expanding and then it will really contract back. We don't have any evidence so far. So what all that we can say firmly is that universe currently at the moment is expanding, because if it was static, then we would not have seen any kind of redshift things in case of galaxies spectra. So based on those observational evidences, we can say that, I mean, static universe concept-wise, it is fine. It could be, but whatever we see, like if you put dots on balloons and you just blow it up, then the dots are going away. That's everything is expanding. And in case of galaxies, since we have got, so we would say that it is expanding universe. We don't see anything about static yet.
Okay, so we are actually closing soon for the question answer session, because we do have an afternoon session. We can still take one or two quick questions. And I will again remind you, there is an option of raising hands from the, in the panel reactions icon. We will attempt to, ask this question again from Haider Abbas from Sherwood. Can we get the quantum effects on a macroscopic scale? So anybody want to attempt to answer that? Yes, Shamrat is again to this.
Yeah. Okay, so the question is, can we get the quantum effects on macroscopic scale? Yes, there are evidence. For example, Zeeman effect is one of the examples. In what happens in Zeeman effect, if you give an intense magnetic field, there is a split of the spectra from the center wavelength. So that we can also see in the astronomic, like observational astronomy, also we use that platform to study various parameters. So in brief, yes, there is macroscopic evidence of quantum effects.
In terms of the quantum modeling also there.
Yeah. So I think it came from the content. Yeah, it's a good. Thanks. Amol Mahajan from Sherwood College. Sir, are the Sir, does every black hole contain a singularity? Yes. Want to answer that?
Yeah.
Yeah. Okay.
It's very difficult to answer, in the sense that so far whatever observational evidences we have are there available for very limited number of such things. And if we talk about a black hole, then it could be all the way from stellar scale to maybe galaxy scale, because there could be solar mass, few solar mass of the order of few solar mass of a black hole, and there could be some 10⁻⁶ solar mass and 10⁸ solar mass of a black hole. Even we ourselves, if our volume reduced to around 1×10⁻⁻28 times to what we have, then probably we would also act like a black hole. So the range of black holes are quite wide. So at the moment, I would say, with the current idea and knowledge that we have, and even if you talk about curved black hole, that's a rotating and non-rotating kind of concepts, based on whatever we have formulated so far, it's very hard to speculate and say that this kind of idea exists in case of every black hole. We definitely need more observational evidence.
Thank you. Ronak, as usually, have another question. Sir, are the planets more in the universe or stars?
Well, again, I would say that, as I said, that in our Milky Way, 10 to the power 11 stars are there, and similarly, the number of estimated galaxies in our whole universe is around 10 to the power 11 itself. So each and every galaxy is supposed to have 10 to the power 11. So 10 to the power 11 multiplied by 10 to the power 11 is the typical number of the stars that we have in our galaxy from where electromagnetic radiation is coming from. And this electromagnetic radiation is coming only from 4% of mass, and rest of the 96-97% we don't know, probably that is dark energy and matter respectively. Then coming back to the electromagnetic, that if we have 10 to the power 11 stars in our galaxy and our sun is one of them, and the sun is having 8 planets, then you can multiply that number and probably have a rough idea. We are not sure if we have 8 planets or 9th was there, and if we have sub-planets or planets which are not defined or they are so faint that we do not know. And if they are there, then they could not be radiating at the electromagnetic spectrum yet. So if you multiply and say that each star is having definitely more than 1 planet, then number of planets are typically should be larger in comparison to number of stars, provided each star is having, and probably whatever evidences we know so far from our study of exoplanets, it seems that each and every star must have planets. So I would say broadly, probably if I'm not wrong, the number of planets is more than number of stars.
Thanks, Shashi. So next question from Ronit from Sherwood. Sir, do all the galaxies rotate?
Well, you know, the galaxy rotation curves, it's very difficult to measure, first of all, because in galaxy rotation curves, and using Kepler's law, especially if we talk about galaxy rotation curves, then if you measure that from, you know, in our Milky Way, we are sitting not close to the center, but at a distance of 2/3 from center. That's our solar system. And sitting there, somehow we have measured for certain number of stars, it was possible to measure that how they are moving and what speed they are moving. So in case of our galaxy, yes, we do know that actually the galaxy itself is rotating on its axis. And also we know that in some case of in case of some of the bright, very big elliptical galaxies and other spiral galaxies also we know. But the rotation itself, direct measurements of those rotations on the time scales which we are currently at the moment, it's very hard to see them directly. But yes, whatever we have seen, evidences indicate that they are rotating, probably in comparison to the central supermassive black hole sitting at the center of those spiral galaxies.
Okay, so I think we'll take the last question from this session, which is again a difficult one. Do white holes really exist? If yes, how are they formed? So this will be attempted by Anjasha.
Okay, so theoretically, you can say that it's the opposite of black hole. We can say that energy, matter, these things can escape. However, there has been no evidence of it till now. We cannot have a point of singularity there, of course, but we can calculate something opposite to a black hole and have a theoretical estimation of it.
Thanks, Anjasha. I think we will break now because we have a good afternoon session also. So I will request you to come back at 2, and there are more interactive options there as well. So you can think about your questions. You can leave your sessions on as well. So we will not close these Zoom session. It will be just muted. So we will come back and meet you all at 2 o'clock.
Yeah,
so
and please do join us sharply at 2, because we have plans to first run the virtual observatory tour and then extempore, and your extempore topics have already been provided to your respective teachers. So if they haven't told you yet, please ask them that what kind of those topics are, which are going to be asked for the extempore session, and in extempore session, managers would randomly again ask those topics randomly to any one of you, and the sequence would be same. That's alphabetically those teams would be decided that alphabetically it is the number 1 is Birla, number 2 Don Bosco Boys, number 3 Don Bosco Girls, 4 Parvati Prema Jagati, 5 Sherwood, and 6 St. Joseph's College. So that we are going to follow the same trend. So see you at 2. Thank you.
Thank you very much. Thank you.
उनको पता है कि वो जज है हाँ मैंने बोल दिया
Score in 10.
Three division understanding or presentation. Okay.
So understanding, correctness and
Correctness.
Good afternoon, everybody. Good afternoon, students. Good afternoon. So welcome back in the second session, and the first session went on very nicely and with all your supports and help and very interactive discussion. So as scheduled, second session we are going to start with one of the virtual tours to the observatory, where it's a 15 minutes documentary primarily based on ARIES and related activities. So this is just for all the students who are participating today. And after watching this documentary, we will go for 5 to 10 minutes of short question answer session, if at all we have. Otherwise, you are always most welcome to use chat boxes of Zoom, YouTube, and Facebook, and one of us should be able to answer. So now we are going to run the virtual observatory tour. Please watch it carefully before you ask questions.
A very good afternoon to you all. As you all know that we have assembled here to celebrate National Science Day. So let's talk something scientific, and please allow us to take you to the virtual tour of our observatory and the sites here. So I am Andromeda.
ऑडियो आ रहा है आप लोगों का? आप लोगों को ऑडियो सुनाई दे रहा है बच्चों?
Yes, sir.
Yes, sir. Yes.
Yes.
Yes, sir.
Yes, sir. Yes, sir.
So it is not audible anymore. Yes, sir.
A very good afternoon to you all. As you all know that we have assembled here to celebrate National Science Day. So let's talk something scientific, and please allow us to take you to the virtual tour of our observatory and the sites here. So I am Andisha Kangopadhyay, a post-thesis submission fellow working in ARIES Nainital in the field of extragalactic astronomy. And I have with me 3 of my colleagues. So please introduce yourselves.
Good afternoon, everyone. My name is Vivek Kumar Jha, and I'm a PhD student. I'm a senior research fellow at ARIES, and my thesis is based on the research in extragalactic astronomy.
Hello, good afternoon to all. My name is Mahendra Chandrajwar. I am a senior research
fellow at ARIES Nainital. I am working in Atmospheric Science Division.
Good afternoon, all. My name is Prajwal Singh Rawat. I'm a senior research fellow at ARIES Nainital. I'm working in Atmospheric Science Division here at ARIES. So after having a brief introduction of all of us, now we are taking you all in a virtual tour of our observatory.
Okay, so good afternoon, everyone. So we will start the tour of the observatory. I'll just share my screen. Yeah. So this is a very unique opportunity for all of us because we are used to hosting you people in our campus, but due to this COVID-19 pandemic, we have not been able to organize in-person events. So this is why we have organized this virtual tour. So in the front panel, you see our main institute. This is the building. This is where we work. This is our office. And on the behind, you see the dome of our telescope. So we'll explain all these things one by one. So before we start, I'll just zoom into our location where we are located. So see on the Google Earth here, you can see that we are located in the foothills of the Himalayas. And this mountain, this is known as Manora. So we are located on the peak of this mountain, which is the Manora Peak. Hence, the location of our institute is at Manora Peak. So now what happened is that earlier when the institute was set up in the 1950s, there was not much of light pollution and the tourists were also very less compared to what it is today. But now what happened is that we have a lot of light pollution coming in from Nainital. As you can see in the stock photograph, that the light pollution is very difficult for us astronomers to work. So hence we decided to move to a campus, Devastal, which is 60 kilometers further away inside the Himalayas. Now, this is a view of our campus. So you can see in the plains of the city Haldwani is located right across our campus. And on the top, you can see our telescope sitting beautifully here on the top. Now the thing is that why we need to do astronomy on the top, on the hilltop and all those things like that. So what happens is that on the hilltop, you can get the turbulence of this atmosphere is very less, one. Other thing is that the light pollution is very less, which is evident as we are here in the mountain. So you can click this beautiful photograph even using your cell phone. So these couple of photographs that you see here, they were taken using cell phone cameras from our campus only. Okay, so now we'll start the tour of our observatory. Our facilities one by one. So now I'll hand it over to Anjisha. She will explain all the facilities that we have.
Okay, so as Vivek has described, let us take you to the facilities that are present in ARIES. So you see in this picture the 3.6 meter dot, 1.04 meter Sampurnanand telescope, 1.3 meter Devastal fast optical telescope, and the 4 meter liquid mirror telescope. These are the 4 astronomical facilities. In addition, we have this 15 centimeter solar telescope for solar observations, and for atmospheric sciences, we have this ST radar facility here in ARIES. So let's move on to and focus onto the site, that is the Manora campus. So the main facility that is present in the Manora campus is the 1 meter Sampurnanand telescope. So here are a couple of videos which we are going to explain on how this facility works. So if you look into the first video, we give you a glimpse of the gate in which we enter the campus. And then we have this beautiful skies around the site. We have this dome rotating, and here you see the first glimpse of the Sampurnanand telescope. So now let me allow you to take a virtual trip to this observatory site. So if you move on to the second video, you see that we are entering through the gate of Sampurnanand telescope. So here you see this is the 104 centimeter and one of the oldest telescope of ARIES. You see a group of budding astronomers working here. So here this is the charge couple device, which is the camera which gets cooled so that thermal electrons are not generated. You see this big tube flap. So here this is inside the tube we have the primary and the secondary mirror through which lights get reflected, and that gets focused, and we finally image it through the camera. We have this slit opening through which the XY coordinate of the object is being tracked, and the dome and the telescope moves accordingly so that the image can be captured in the camera. Now these all are controlled through this console or this control panel in which you will see the yellow buttons, and we fix the array and deck, that is the XY coordinate of the object in the sky, and then the telescope moves accordingly. we take the image of the object, that is, we capture the object, and finally what we see is in the computer that we are going to see. So here in this room, you see a group of researchers who are actually analyzing the scientific images. So you see this bright star which is coming, and we analyze its brightness and other physical parameters. So this kind of work is being done here in this telescope. So let's move on to the next slide, in which you see a bright sunny day. So, and this is the observatory and the dome you see. So we go there in the evening, we start our observations, we do full-time observing, and at night you see we are exhausted. But at the end of the day, what we gain is actually the brightness of this wonderful astrophysical sources and their physical phenomena associated with the various astrophysical transients.
Okay, so after having a look at the 1.04 meter component telescope at Manora Peak, now it's time to move towards our other facility, which is located in Devastal. So as you can see in the map, the Devastal campus is located around 56 kilometers away, further inside the Himalayas. And weather here, especially in the winters, sometimes it's very difficult. It's very, very difficult to travel there. As you can see on the left-hand side, this is our vehicle, which takes us to Devastal. It's completely covered in snow. So weather is pretty harsh there in winter. But even the weather is harsh, the road is icy or the nights are chilly, we have to go to observation because that's what our job is, that's what astronomers are doing. Okay, so our Devastal campus is composed of three major facilities. On the left-hand side, you see the International Liquid Mirror Telescope, which is an upcoming facility. On the right-hand side, you see the 1.3 meter, there is the Fast Optical Telescope, which is a running facility. It observes every day, except the monsoon season. And on the behind, you see the 3.8 meter Devastal Optical Telescope, which is the largest optical telescope in India. So now we'll have an aerial tour of the campus to have a glimpse of what kind of facilities are there. So yeah, again here you see on the left the IMT, on the right you see the Devastal Fast Optical Telescope, and as the camera pans in, you see the Devastal Optical Telescope proudly standing on the top of the Devastal campus. The altitude of this campus is around 2,400 meters. So this is one of the highest observatories in India, and the sky conditions there are very good. They are compared with the best observatories in the world. And you can have a glimpse of the Himalayas on the northern side. In the day is very clear, as you can see here. So, yeah. So now I'll just start with the 1.3 meter Devastal Fast Optical Telescope. So this telescope was established in 2010, and it works every day for the past. It has worked every day for the past 10-12 years, except the rainy season. The main feature of this telescope is that it has two cameras. One is the 2000 by 2048 by 2048 CD, another is the 512 by 512 CD, and all these two cameras are used to take images of the galaxies, stars, exoplanets, and all those galactic and extragalactic objects, and a lot of research is being done using this telescope. So this is another view of the 1.3 meter Devastal Fast Optical Telescope. This is an equatorially mounted telescope, and using this, we observe all kinds of stars, galaxies, and extragalactic objects. And this is the telescope control room. Here we gather and analyze all the data that is obtained from the telescope. So on the right-hand side, you see that this is the all-sky view. In the all-sky view, basically, we know where the position of the telescope lies in the entire sky. On the left-hand side, you see the controller. So basically, we have the image here. We take the image in this plane, and this is basically the telescope control system. So from here, we control and move our telescope and all this stuff. And on the top, you see the weather monitor, which gives you a real-time feed of the current weather conditions which are outside the telescope. So this telescope has been in the news quite often in the past few years because a lot of discoveries have been made. You can see the stars from the global system, they have been discovered here. We have also observed the flare from the black hole. We even study open clusters, we study dwarf galaxies, and even we have found a lot of new stars in the Milky Way galaxy. So overall, this has become a very important facility for our campus. So now for another facilities at Devastal campus, I'll hand it over to Anjisha. She will explain the 3.6 meter optical telescope, and she'll also give you a glimpse into the upcoming international 4-meter liquid mirror telescope.
Okay, so as you know that India has been waiting long for a telescope of larger diameter so that distant astrophysical sources can be traced. So we have this facility, 3.6 meter Devastal optical telescope that has been inaugurated by the Honorable PM Narendra Modi in 2016, and ARIES had this beautiful opportunity of getting this telescope in hand. So you can see in principle that this is the crown jewel of astronomy in India, and I can say not only in India, it's Asia's one of the largest telescopes. So this has been functioning since 2016. You see that we have had this beautiful opportunity of tracking and analyzing a large number of astrophysical sources, starting from exoplanets, extraterrestrial sources, to going deep into galaxies, detecting new transients, to studying dynamics of the galaxy. This has been a wonderful experience. So let's go into the virtual tour of this 3.6-meter telescope. So as I have already said that this is one of the largest optical telescope in Asia. It has a unique time zone. It is one of the highest altitude buildings of 2456 meter in altitude. And it's almost a 10-story building. So air pollution and atmospheric turbulence are very less, which makes it one of the best sites of the world. So let's go into the observatory now. So if you look into the first video, you will see that we are entering to the gate of the telescope. This is the main entrance, and the right hand side as we move on, this is the control room. You see a large number of cameras and a number of PCs where actually our scientists are analyzing the in-hand data that we get from astronomical observations. So people are analyzing the data. In this room, we have also the images that are being captured with the 3.6 as you see in this pictures and this inauguration picture. Now see that what in principle the kind of images we get and what in principle this telescope actually operates on. So you see this telescope opening, this is the whole setup where light gets reflected and we get the images in the camera, this wide angle view of the whole observatory. These fans are basically there to control the temperature inside so that there is no thermal heating inside. And here in this picture, you see the image that has been acquired with the telescope. So here, this is a binary star, and this is one of the telescopes which has one of the best resolution, and we could resolve the images up to sub-second limit. So this makes this facility a unique among the set of telescopes that ARIES have. So now, if we move on to the next slide, you see that this is an upcoming facility in ARIES. This is 4-meter liquid mirror telescope. You see the building design here. This is unique in the sense that this is one of the telescopes where there are no primary and secondary mirrors. You have this spherical shaped region where Mercury is there, and you get the image of the astronomical object through reflection. It traces a particular path of the sky. So all the transients and extraterrestrial sources that are being detected in that path can be actually detected through this telescope. So ARIES is waiting for this facility. So now I'll show you some of the beautiful images, night sky images taken with Devastal. So this is a star trail image in which the path of the stars are being tracked at night sky in Devastal. Got to see wonderful sunset and sunrise views here in Devastal, and then this is the final telescope with the dome shining, and you see that there are a number of stars and there is a very deep sky here in Devastal. So this is what you get to see when you come and visit Devastal. And now I will ask my atmospheric group fellows to introduce the facilities that are present here in ARIES.
In addition to astronomy and astrophysics, here at ARIES, we also take up front-end research in atmospheric science with our major focus in trace gases, aerosols, meteorology, and dynamics. In the trace gases, we are studying various greenhouse gases and air pollutant in the atmosphere. In the aerosols, we are studying PM2.5, PM10, black carbon, organic carbon, using both the remote sensing and the chemical analysis technique. In the meteorology, we are recording the temperature, humidity, winds, pressure, and the precipitation over this mountain top. To study the various dynamical aspects over this Himalayan region, where various extreme events like cloud bursts, heavy rainfall, cyclonic events occurs, we are using our major facility ST radar for monitoring these events comprehensively.
To investigate the different dynamic processes of the atmosphere, ARIES ST radar facility developed in 2015. It is a unique facility over the central Himalayan region, having an array of 755 antennas. It works on the principle of the radar. If the radio signals transmitted into the atmosphere, it gets reflected back to the ground. And by analyzing the received signal, we can find the wind information of the atmosphere. ARIES ST radar facility uses single antenna for receiving and transmitting of signals. This is situated over the roof side of the top of ST radar building. This facility has maximum height coverage for up to 20 kilometers from the ground. Whereas by using this facility, we can do the detailed study of the extreme event like thunderstorm, cloud burst, heavy precipitation over the central Himalayan region.
In addition to radar, we also have trace gas observations at ARIES Nainital. This is our atmospheric lab, where most of the dedicated instruments are installed. We have greenhouse gas observations. We have observations for air pollutants like NO2, carbon monoxide, ozone. We are also having a gas chromatograph for studying the non-methane hydrocarbon content in atmosphere. We are also launching the balloon in atmosphere to record the temperature, humidity, winds, and ozone in the atmosphere from surface to 35 kilometers above ground. So this is a simple representations of the lab where our colleagues are working, operating these instruments, analyzing the data, and coming up with very interesting results. Apart from the surface-based observations, we have also set up a LIDAR facility at ARIES Nainital. So in this LIDAR facility, we are shooting a laser beam in the atmosphere, and its backscatter is recorded at the ground. With this unique facility, we are studying the suspended aerosol particle in the atmosphere from surface to 6 kilometers above ground. So here in this recorded video, you can see how the dedicated scientists and engineers are operating these instruments. They are controlling the laser beams and shooting it into the atmosphere and recording the data.
So in the continuation of different atmospheric facilities at ARIES Nainital, ARIES Nainital also have a meteorological tower to access the different meteorological parameters such as temperature, humidity, solar radiation, pressure, wind direction, and wind speed. We have recorded these data in two different heights, and with addition of these sensors, we also set up some solar soil moisture sensors.
I hope so you all enjoyed this observatory tour. We tried our best to give you a glimpse of what we do here in ARIES. So I wish you all the best for future ahead. So if you look into this picture, you see that we had wonderful times here in ARIES where a lot of people gathered, and we actually pursued outreach activities here in ARIES in person. But unfortunately, due to this persisting COVID situation, this has not happened. But we hope that sometimes in near future, we hope to see you all again in person here in ARIES. Okay, so I hope you all have enjoyed this, and we are signing off now. So I extend my comments to my colleagues if they want to say something, and bid goodbye to you all. So goodbye.
So in case you have a couple of questions, because some of the questions we can take up later after balloon experiment, but one or two, if you have, then you are most welcome to ask, and we should be able to respond. All right.
If not, then just to maintain and keep the time as well, let's move to the second important event of this afternoon session, where we have again, like in the first half session, we have 6 teams. First is Dan Bosco Girls College. Sorry. Yeah. That sequence is there, but I have my own. So I'm not naming those names in sequence, but just to name total number is Harshita Tomar, Asmi Raj, Riddhi Tuli, Ipsita Biswas, and Sargam Soni. So this is just to inform you that these are the 5 names who are there from Dan Bosco Girls College. So let's clap for them. They are the participants. Then Ranjot Singh, Ayush Shukla, Umang Tyagi, Vasu Agrawal, Tejas Sharma, Ishan Raghuvanshi. So these are from Dan Bosco boys who performed very nice in the first half. So welcome them. For extempore session in Kerala, we have Kaustav Pandey, Nakshatra Kanchan, Parvan Basne, Gaurav Singh, and Yashansh Agrawal. So clap for those. And then from St. Joseph's College, we have Ayan Raj Bajaj, Hars Bhatt, Manas Tiwari, Arav Bora, and Sivam Adhikari. So these are 5 names from St. Joseph's who are going to participate. And then from Sherwood College, we have Himang Singh Jalal, Amol Mahajan, Saurabh Singh, Ronak Agrawal, Haidar Abbas. So these are the 5 names which we have from Sherwood College. And I don't have any clear 5 names from Parvati Prema Jagati. So I will read all 10, probably 5 of them will be there. So Kushagra, Ansuman, Rachit Vikram, Samarth Bharadwaj, Dipanshu, Aro, Arpan, Aryan, Ayan, and Rishank Ranjan Maurya. So out of these 10, 5 have already participated in quiz, and rest 5 will participate in here. So I have little highlighted, and the extempore questions have already been given in the emails before I hand over to the team of extempore activity who are going to tell you the details. I would like to inform that the topics are already given. 5 of you are participating from each one of the colleges. So we have just decided that only 3 of you will be given chance from per team, and those randomization is done here. Probably you may see near my hands, we have 3 multiplied by 7, that is 21. Yeah, the 21 slips, and randomly after explaining, the team of Jha, Ritesh, and Anjasha, they will explain little more, and after that choose one by one. And you are not supposed to take more than 2 minutes at a time to keep the records. And based on quality of your presentation and your confidence and the real content of that particular topic, judges of 4 members judges team, chaired by Director ARIES, Professor Dipankar Banerjee, would decide that who has the real stuff while speaking about extempore. So please, Vivek.
Okay, so good afternoon, everyone. Okay, so good afternoon, everyone. I hope you're audible to you all. So this is an extempore session. We have sorted all the schools in alphabetical order. So Anisha will pick up one of the chits from there, and then there will be one topic in that chit, and I will call out one of the schools, and the school will nominate one of the speakers in this session. Okay. Yeah. So once I call out the name of the school, you have to get closer to the mic so that we don't have loss of time. So yeah. So we'll notify you that once the 30 seconds are left, so that you keep a track of time while speaking. So 3 students from each school will get a chance to speak. So all of you, I expect you all to get ready. Okay. So there are 3 judges, and you will be judged based on 3 parameters. So one of them understanding of the topic, other is the correctness, and third is the clarity of presentation. So without wasting any time, we'll just start picking the chits. Okay, so Birla School, get ready. Yeah.
Okay, so the topic is Mars mission.
The topic is Mars mission. So one of the students from Birla School will start speaking. Birla School.
And they can do the name who is speaking.
Sir, are we audible?
Yeah, can you please tell the name of the speaker?
Gursahat Singh.
Hussain. Okay, so once I okay, so are you ready?
Yes, sir.
Start.
Good afternoon. This is Gursahat Singh. On behalf of Birla Vidya Mandir, I'm going to talk about on the topic of perseverance of Mars missions of humans. So, knowing and conquering the world of universe is the first and the biggest motive of humans from the beginning of the 1950s. But conquering of Mars and colonizing Mars started in the year 1960 when Roscosmos started the mission 1M number 1 with launching the launch vehicle Molniya 8K78 rocket on 1960. But it was a failure because the rocket couldn't catch the orbit on time and lied as a space debris. So on the year 1965, NASA tried to launch Mariner 4, which was a perfect success, and it was a flyby mission which took 26 images of Mars and came back successfully back to Earth. So after this, several missions occurred like Mariner 6, Mariner 7, Viking 1, Viking 2, Mars Odyssey, Mars flying missions were also done. But if we specifically talk about India, India has done only one mission, that's Mangalyaan, or we call it MOM, that's Mars Orbiter Mission. It was done on 2013 with the objective to launch, with the objective to study Mars and its surface. And by taking the orbit successfully, India became the first nation to successfully orbit Mars on its first attempt.
Now 30 seconds left.
So total of 65 missions have been done from 1960, and about 24 of them have been successful and 5 of them have been failure and partial success, and half of them are totally a failure. And we can say that it's just a step forward and there's a whole way ahead to study the whole universe. Thank you.
Okay, nice. Okay, so the next thing is from Don Bosco Boys School. Please get ready. Don Bosco Boys School.
Okay, sir.
And the topic is
effect of lockdown on air pollution.
the topic is effect of lockdown on air pollution. Don Bosco Boys.
Good afternoon to all.
Just before you start, can you please let us know your name? Sorry, can you please speak? Hello. Okay.
You have to come a little closer to the microphone.
Ayush Shukla.
Ayush. Okay, Ayush. So Ayush, your time starts now.
Good afternoon to all. Today I am here to share my views on the topic. In the process by which the of planet's atmosphere warms the planet's surface above the
Sorry, we are interrupting you. Yeah, your voice is not very clear, but you know, can you try to do something to come closer to the laptop or whatever you are using?
Please come closer to the mic. The voice is not very clear to us.
Yeah, we'll start your time again. Don't worry. So you can start from afresh. Go ahead.
Good afternoon to all. The topic is greenhouse effect. Greenhouse effect. It is the process by which radiation from a planet atmosphere.
Ayush. Hold on. The topic is effect of pollution, lockdown on air pollution. The effect of lockdown on air pollution.
Okay. Yeah, if you can start, we can link it with greenhouse. So let him. Go ahead. Go ahead. Start from fresh. Yeah.
Of air pollution on lockdown were very simple. That when lockdown was there, the transport became very less, so that pollution was not done too much, as the vehicles were not moving on the roads and the transportation also was decreased, which led to decrease of air pollution. Many things can increase the air pollution, But the lockdown was a very helpful thing that helped the nature, as in many ways the air pollution was decreased, water pollution and many pollutions were decreased. So the lockdown was very effective on air pollution, reducing air pollution, as people always use vehicles for traveling shorter to shorter distance. But during lockdown, no vehicles were moved on roads, so that's why air pollution was decreased. People, after some years, when air pollution will be at its peak, people would be forced to not use vehicles, as there would be no option for them. If the air pollution would increase too much, then the life could also do not exist after that. So air pollution is a very vast topic which can be talked about. Lockdown has affected a lot on air pollution, as it was not easy to decrease air pollution, but it was all successful due to lockdown. So this can come in an advantage of the COVID-19, as all no other advantages are there.
You have 30 seconds left.
Has decreased air pollution. Air pollution was a very major factor before this. So if it has helped in decreasing it, we can consider it a very great achievement of ours. Because air pollution has taken death of many, as asthma patients can face various problems by air pollution, and many things can happen to them. So we can say, at last, I can say
Time's
that.
up.
Thank you, sir.
Next is Don Bosco Girls. Please get ready. Don Bosco Girls. Okay. So now we are picking the topic.
Okay, it's the same topic again, Mars mission.
Oh. So Don Bosco Girls, one of you have to speak on the Mars mission.
बट सबका 3-3 सेट है Okay, so the topic is Raman effect.
Okay, so where's the Don Bosco Girls School? I'm not able to see your video.
Yes, sir, I can see it. I can see it. They're there.
Okay.
When they start talking,
Yeah. So the topic is Raman effect. Yeah. So topic is Raman effect. Speaker, can you please let us know your name?
Yes, you are.
Yeah, you're audible.
Yes, good afternoon, everyone. My topic is Raman effect and myself, Riddhi, from Don Bosco Girls College.
Okay, Riddhi.
Raman scattering or Raman effect.
Wait, Riddhi. I'll let you know when to start. Yeah, start now.
Okay. Raman scattering or the Raman effect is the elastic scattering of photon by matter, meaning that there is exchange of energy and change in light direction. Typically, this involves vibrational energy found by a proton being gained by a molecule as shifted to lower energy. This is known as normal stock Raman effect. This phenomenon is named after a great Indian physician named CV Raman in 1928. Scientists believe that sea looks blue because it reflects the color of sky. But Raman found that it was water itself responsible for the blue color of sky. The sky is exploited by physics to gain information for performing various of Raman spectroscopy. Many variants of Raman spectroscopy allow rotational of energy to be examined and electronic energy to be examined if an X-ray source is used. An X-ray source is used to form various other possibilities. Light has a certain possibility of being scattered by every material. When we talk about photon, when we talk about photon, it's scattered the most. Most of them are electrically scattered, such that scattered photons have same wavelength, frequency, color or energy, but different direction. This is all about Raman effect. That's all. Thank you.
Thank you. Today is Parvati Prema Jagati, and we are taking up the topic now.
Space weather.
The topic is space weather. So Parvati Prema Jagati. The topic is space weather.
Just a minute.
Yeah. Okay. So speaker, please let us know your name.
Hello everyone, my name is Conrad.
Can you please come closer to the mic? Your voice is low. Yeah. Yeah. Please let us know your name. No, she's not on. Yeah, please,
just say something, otherwise we will not know, na?
Yeah, speak loudly. You are also speaking very slowly.
Excuse me, are you able to hear?
Yeah, we can hear
Yes, we can hear the other voice, not the one who is in front of the camera.
Hello. Yeah, this voice is clear.
I have to sit closer to that.
Yeah.
Or you can move camera closer to.
Yeah, you're audible, but your voice is very low.
तुम वहाँ माइक के पास जाके खड़े हो जाओ, वहां से बोलो.
कैमरा को डायरेक्शन में करो, कैमरा को डायरेक्शन में करो और आप बोलो.
माइक जहाँ पे है उसका नजदीक हो जाओ. जो माइक टेस्ट कर रहा था उसका वॉइस आ रहा था.
सर ये ब्लूटूथ काम नहीं कर रहा है.
आप कैमरे का डायरेक्शन चेंज कर दीजिए, स्टूडेंट को माइक के पास खड़ा कर दीजिए. कैमरे का डायरेक्शन चेंज करके स्टूडेंट को माइक के पास खड़ा कर दीजिए.
हेलो.
Yes, your voice is clear.
Very good. Sound is very good.
Portable mic.
What's your name? Yeah, say your name again. You're quiet. We can't make out, na?
Hello.
Say something.
Student.
वैसे बात है.
जो माइक टेस्ट कर रहा है उसका आवाज साफ आ रहा है.
बात ठीक है. वैसे बात नहीं कर रही.
जो बात ही करेंगे तभी ना पता चलेगा.
अपना नाम बताओ.
Yeah, move on. Just go ahead. Say your name and go ahead.
नहीं, बट वो कुछ रिस्पॉन्ड नहीं कर रहा. अपना नाम बता सकते हो?
हेलो हेलो हेलो.
हमारी आवाज आ रही है?
कुछ रिस्पॉन्ड नहीं हो रहा ना. यहाँ से तो ऑन कर दिया कि हमको.
See, the people who are sitting in the back, we can hear you, but the person who is sitting in the front, we can't hear you because you are not speaking.
Can you hear us?
Hello, student.
Hello.
हमारी आवाज आ रही है?
हमारी आवाज आ रही है?
स्पीकर वो कुछ खुल दिया होगा.
हमारा माइक तो चल रहा है.
कनेक्टिंग टू ऑडियो.
आवाज आ रही है?
टेस्ट करो सर एक बार.
No.
आवाज आ रही है?
उनकी आवाज आ रही है? They are not able to hear us. Okay. No, they are not able to hear. So we will move on to the next view, right? Not waste that much.
Send करने से पहले 2 चेंज कर देना.
ये 2 में पार्वती
हंसी आवाज नहीं आ रही है।
हेलो हेलो
नहीं कर रहे। हम लोग को ठीक है। हेलो हेलो देखिए टेस्टिंग
क्या सुन रहे थे हम लोग?
हम next
Move on to the next.
Okay, so
you set up and then
okay, so we move on to the next participant. We'll just let you set up for some time.
We'll move to the next participant.
So अब बोलिए कि we are moving to the next participant.
आराम से अपना setup बना लो.
We'll come back to it. We'll come back.
We are moving to the next participant. We will return.
Okay, so we are moving to the next participant for now. वही हम कर रहे हैं।
हाँ पांडे जी कुछ प्रॉब्लम आ रही है वहां से ना आवाज नहीं आ रही है।
हम आपको सुन पा रहे हैं, आप हमें नहीं सुन पा रहे हैं।
Okay,
उसका सेटअप पे देखिए उनका माइक्रोफोन।
ओके, आप दोबारा रिजॉइन करिए, तब तक हम दूसरे पार्टिसिपेंट को जाते हैं। ओके ओके, थैंक यू।
Okay, so the next participants are from Sherwood. Okay, so now we are taking the topics.
Black holes.
The topic is black holes. So Sherwood, please nominate one of you for speaking.
Yes, this is Heather Abbas from Sherwood College,
Okay.
and I would like to speak on the topic.
Okay.
Am I audible?
Yeah, you're audible. Please hold on for a second.
हैदर अब्बास को पिन कर दो।
वो बोलेगा तो आ
आप
जाएगा।
बोलेगा तो आ जाएगा,
इसमें
हम पिन कर देंगे।
Okay, Heather, you have to get ready. So, yeah, your time starts now.
With the idea of exploration in our mind, we have reached far, far away from Earth, and we have discovered a strange thing known as black hole. According to Einstein, a black hole is a place where God divided by zero. A pretty hypothetical idea, but yes. It reminds us, and I personally like black hole and I'm interested in it this way because it reminds us that space can be crumpled like a piece of paper, that time could be just blown away like a candle, and the sacred laws of physics can easily be muted. With a gravity so massive that matter is squeezed into tiny space and stretched like elastic band, nothing escapes from it, not even light. It is formed by a dying star collapsing inward on itself, which has exhausted its energy and outer layer and is blown away. The surface of the black hole is called the event horizon. It is the boundary of the black hole. If you need to escape the event horizon, then the speed should be more than the speed of light, which, for according to theory of relativity, is the speed limit of the cosmos. So you will have to work pretty hard. By falling into a black hole and coming under its gravity, there is probably no turning back. Time slows as the gravity of the black hole increases. The strong gravitational forces of the black hole will stretch the body like spaghetti and elastic band. The person's body will be ripped apart even before they enter the event horizon. But the person watching you from the distance will see an entirely different movie after all. They will see you slowly going into the black hole and then diminishing away from the existence. This happens because as the gravity increases, the time stops and the space keeps on moving. The black holes are of 3 types as we know so far: stellar, 2 to 3 times of the mass of our sun; supermassive, found in the center of the galaxy, weighing much more than the solar masses, thousands and thousands of solar masses; and the smaller ones, which are called the immediate.
Your time is up now.
All right, so I would just like to end by saying that we all thought what's happened inside a black hole stays inside a black hole, but no. The new theory discovered from the past 50 years of the famous scientist Stephen Hawking discovered the Hawking radiation, which emissions come out from the black hole. And I've always wondered how to create a black hole. Can I create a black hole in my room? But no, that is impossible, because if you want to create a black hole, then you have to crush Earth to the size of a small peanut with a radius small than 9 millimeter. Thank you.
Okay, very good, very good. Okay. So the next school we have is St. Joseph. And we are picking up the topics now.
So the topic is space weather.
The topic is space weather. So St. Joseph, please nominate one of you for speaking on space weather. Ah, yes, they are here. You are muted. Yeah. So who is speaking? Okay. You are muted again.
Harsh Bhatt can speak.
Yeah.
Sir, Harsh Bhatt will be speaking from our side.
Can you repeat the name, please?
Harsh Bhatt.
Harsh Bhatt. Okay. So Harsh, your time starts now.
Space weather.
Good morning, everyone. My name is Harsh, and I'll be speaking about space weather. To be honest, my knowledge about space weather is kind of pennyworth. So I know that space weather has to be something related to the orbiters rotating around our planet, seeing changes in like sort
Can you
of.
please come in front of the camera?
He's in the front. We have wrongly pinned. Harsh.
So I'm attending. So like I'll be in.
Yeah, he's
Okay. Sorry. Go ahead. Yeah, please.
So it has to be something related to the sun rays reaching to our planet and what happens like in the meantime of 3 minutes and 8 seconds, like what happens while that time span. So it has to be something related to electromagnetic field lines which the scientists observe via telescopes or maybe orbiters around the Earth. I read it somewhere that it takes around 18 hours for like the climatic changes in the magnetic field to be observed, which help us in uh, uh, observing these changes. And the study of space weather has been like new to us. Like it has been used by army militaries and weather departments uh, freshly during the 20th century only. Like it wasn't one of the earlier discussed topics. So it is quite new to us, and I think weather forecasting would have been like done on the basis of this. That's all I know. Thank you.
Okay.
Now we'll again get back to Parvati Prema Jagati. Is your voice clear now? Parvati Prema Jagati.
Yes, sir. We can hear you now.
Okay, so we can also hear you. Your voice is much clear now. So we are giving you a topic.
So the topic is extraterrestrial life or extrasolar planets.
Okay, so the topic is extraterrestrial life or extrasolar planets. So please nominate one of you for speaking. Okay. Your voice is still not clear. पीछे
Now, the humans keep looking for the.
थोड़ा माइक के पास आइए. ओके, और थोड़ा जोर से बोलना है.
We tend to focus to find other species.
Okay, wait. अभी स्टार्ट नहीं करना है. अभी स्टार्ट नहीं करना है. हम आपको टाइमर देंगे तब स्टार्ट करना है. अपना नाम बताइए पहले.
I'm Tanishq.
Tanishq. Okay, Tanishq. So Tanishq, your time start. थोड़ा जोर से बोलना Tanishq. Okay, so get ready. Your time starts now.
Life exists on Earth, and the logic goes on that there are other species other than us in different planets, and these are very, more in numbers like billions and trillions. That's the fact that they will not be existing in the same planets, same as the Earth, and they will not be same as the humans. So, more precisely, they will be more larger than us and will be living in small planets with small populations. So, this is that it can be proven with simple physics and some fancy statistics that the we humans are more complex and intelligent creatures than the others, and the thing goes on that intelligent creatures need complex bodies and are bigger in sizes. So, and for example, mm, there I mean to say more bigger sizes. For example, a complex organism, there are more elephants on the earth, that a bigger organism needs a bigger land mass to live, as the countries with bigger populations have large land masses. And more precisely, let's
30
compare
seconds.
a small ant there are many ants than elephants in the earth. So as we conclude, humans are complex and small creatures, so we are most likely to be abnormal to other extraterrestrial creatures. So for finding extraterrestrial intelligent organisms, we should focus on planets much more smaller and much more darker and much more dark.
Time's up.
Thank you, sir.
So now we have finished round one. So we'll again go back to the schools one by one. So Birla School, get ready. Okay, so now we are picking the topics.
नहीं करते हैं stop. Space weather ही है. कौन सा स्कूल है?
बिरला स्कूल.
वो देखना कि एक ही टॉपिक मतलब एक
बस तीन शीट्स है ना?
एक स्कूल को दो
नहीं
फर्स्ट उन्होंने शायद
टॉपिक
मार्स मिशन तो अभी स्पेस वेदर.
Okay, so Birla School, get ready for speaking on space weather. One of you please come forward. Birla School, Birla Vidya Mandir. Video on है, mic नहीं है. Can you please unmute yourself? ठीक है. Yeah. Please let us know your name.
Sir, am I audible?
Yeah, you're audible.
Shall I start?
Please let us know your name first.
So it's Kostov.
Kostov. Okay, Kostov. So your time starts now.
A very warm good afternoon to when and all present here. I, Kostov Pandey, is here to speak on the topic space weather. Space weather contains the rather rapid variations in the Earth's magnetic field due to the electric current present in the ionosphere and magnetosphere. However, the process that results in this change heavily depends on the external as well as internal sources. But majority of the part of this weather depends on the internal sources, that is the core. Earth has a strong magnetic field that varies in both in space and in time. The major part of it is produced by a self-sustaining dynamo present at the depth of 2,900 kilometers. And the core, if I have to be specific, it is made up of nickel and iron, majority of its part. Several sources contribute in this magnetic field above the Earth's surface, and by the largest majority of the part is produced by the electric current generated by the fluid motion in the Earth magnetic core. This so-called core field is responsible for more than 93% of the magnetic field produced. So at last, I would like to say that I want to express my gratitude to ARIES and Birla Vidya Mandir to allow me to express my views. Thank you.
Okay, fine. So the next is Don Bosco School boys. Please get ready.
Okay, so the topic is black holes.
The topic again is black holes. So Don Bosco, boys. You have to speak on black holes. Please unmute yourselves.
Good afternoon, everyone.
Okay. So what is your name?
My name is Dipankar Banerjee, and I am here to speak on the topic black holes.
Your voice is not clear. Can you please come closer to the mic?
My name is Dipankar Banerjee, and I am here to speak on the topic black holes.
Okay. Okay. So your time starts now.
Black hole is a region where gravity is so powerful that light can't escape. The theory of general relativity predicts that a sufficiently compact mass can be formed the space-time to form a black hole. The boundary of the region from which no escape is possible is known as the event horizon. Although this event horizon has an important and enormous effect on the circumstances of an object passing through the black hole. According to the general theory of relativity, it doesn't have any locally findable and detectable features. The black hole may act as a black body as it does not reflect anything, including electromagnetic radiation, such as visible light. If we throw an object in the black hole, it will never return back to its original position due to the strong gravitational fields in the black hole. Objects having the highest and the strongest gravitational fields were firstly considered by John Simon and Mitchell Perry Laplace in the 18th century. Black holes may form when the very giant stars collapse at the end of their life cycle. The black holes can make themselves more and more dense by absorbing the mass around them. Black holes
30 seconds.
At the core of the Milky Galaxy, there present a supermassive black hole with about 4.3 million solar masses. Thank you.
Okay.
Okay.
I just want to make one point clear. You see, this is called extempore. That means you have to say without seeing any papers or anything written around you. So we are observing that occasionally some of you are taking help of some scripts, and the marks will be deducted for that. So please be aware and accordingly take it up next time.
Okay, so the next we have Don Bosco girls. So the topics, we're just picking up the topic now.
Topic is Raman effect.
The topic is
नहीं, क्या हुआ था पहला?
okay, so Raman effect, we are replacing the topic, and topic is
Mars mission.
Mars mission.
ये ना?
Am I audible?
Yeah, you're audible.
Hello, am I audible?
Yeah, you're audible.
Okay, good afternoon, everyone. I'm Asmi Raj, and I'm going to speak on the topic Mars mission.
Okay.
Elon Musk, the founder and
Hold on.
CEO.
There's a timer, so we'll just let you know when to start. Okay, so start now.
Elon Musk, the founder and CEO of SpaceX, said, "Land on Mars, a round-trip ticket, $500,000, it can be done." The red planet Mars, named for the Roman god of war, has long been an omen in the night sky, and billions of years ago, this planet could have been mistaken to be Earth's twin and have presence of liquid water on its surface and maybe even life. Now the world is a cold, barren desert with few signs of liquid water, but after decades of study using space probes, rovers, and other technologies, scientists have revealed Mars as a dynamic, wind-blown landscape that could just maybe harbor microbial life underneath its surface even today. Since the 1960s, humans have reportedly explored Mars beyond any other planet except for Earth. Currently, 8 missions from the countries United States, Russia, European Union, and India are orbiting Mars or continuously roving across its surface. NASA's InSight mission aims to study how the seismic waves travel through the core of the Mars in order to reveal interior mysteries of the Mars. Marking India's first venture into space,
MOM, that is Mars Orbiter Mission, is going to explore the Martian surface, its morphology, mineralogy, and the Martian atmosphere. Elon Musk is building a spacecraft that will take humans to space, and it's called Starship. Well, there are many other researches going on, and maybe in the near future, there could be possibilities that after all these technologies we can have in the future, we might even land on Mars. Thank you.
Next is Parvati Prema Jagati. So the topic
Is extraterrestrial life or extrasolar planet?
okay. So
Same planet, same topic. Change the topic.
okay. So
Greenhouse effect.
yeah. So the topic is greenhouse effect. Parvati Prema Jagati. Topic is greenhouse effect. One of the speakers. Okay.
My name is Samarth Bhargava and I am here to speak on the topic greenhouse effect. So, as you know,
Repeat your name, please.
my name is Samarth Bharadwaj.
Samarth Bharadwaj. Okay, Samarth. We'll let you know when to speak.
Okay, my name is Samarth Bharadwaj and I am here to speak on the topic.
Okay, so your time starts now.
I'm here to speak on the topic greenhouse effect. So, as we know, on our today's environment, we see a lot of pollution and a lot of acid rains and global warming. This is due to the main cause of it is greenhouse effect. The greenhouse effect is the rising of temperature due to the harmful gases like CO2, SO2, etc. These gases can be produced by the pollution and also by the burning of coal. These gases are very harmful as they affect in the ozone layer depletion, they affect in the breathing diseases, and they also affect in the rising of the temperature of Earth. To prevent the production of greenhouse effects, we must forward to stopping the use of burning of coal, burning of natural fuels, burning of plastic, and avoiding the use of vehicles as they produce CFCs, chlorofluorocarbons, and they produce carbon monoxide, which is very harmful for our ozone layer and also for our environment. The greenhouse effect also states that it makes the depletion in our environment, and it also causes a very harmful diseases for humans, like they cause skin disease and they also cause breathing diseases to many animals like humans. And also they are affecting the plants of our environment. The plants are affected by them, so as the lifespan of many plants have been declined, and also the lifespan of humans have declined, and also as we know they are also affecting the birds. The birds are the major decline in today's world. Thank you and have a nice day.
Next score is Sherwood. Okay. So Sherwood, the topic is
Mars mission.
Mars mission. So who will be speaking
Sir
of-
Saurabh Singh of Sherwood College.
Oh, Saurabh, we cannot see your video. Have you turned it
Yes,
off?
sir.
Saurabh Singh.
Am I visible?
Yes, you are visible now.
Am I audible?
Yeah, clear.
Okay. So Mars mission.
Wait, Saurabh.
Mars. Yes, sir.
Sorry, so there's a timer, okay?
Yes, sir. No problem.
Okay. Yeah, so the timer starts now.
Mars 2020 is a Mars rover mission by NASA's Mars Exploration Program, which includes the rover Perseverance carried in the rocket Atlas V. The rover was launched on 30th July 2020 at Cape Canaveral Space Force Station and made its successful landing on Mars on 18th February 2020 at Jezero Crater. Major objectives of this rover are: 1. Looking for habitability by identifying host environment that were capable for supporting microbial life. 2. Seeking signs of possible past microbial life in those habitable environments. 3. Collecting core rocks, recoil samples, and storing on Martian surface. 4. Preparing for humans by oxygen production for Mars's in atmosphere.
Perseverance, nicknamed Percy, is a car-sized rover only a few centimeters larger than its predecessor Curiosity. This rover was built by Jet Propulsion Laboratory and is flourished with 7 payload instruments, along with modified cameras, modified wheels, and microphones. This rover will be exploring the Jezero crater, which scientists speculate was a 250-meter deep lake over 3.5 million years ago. Curiosity, Spirit, Insight, and Opportunity are all previous Mars rovers and qualities we humans possess. We are always curious and seek opportunity. We have spirit and insight to explore Mars and outer space. But the most important quality of all is perseverance. We have faced a lot of setbacks in trying to explore the red planet, but we didn't give up and kept moving. And so will we to dare mighty things. Thank you.
Okay. So the next school is St. Joseph.
And the topic is greenhouse effect.
Topic is greenhouse effect. St. Joseph School, college. St. Joseph Yeah.
Good afternoon, sir. Shivam Adhikari will be speaking.
Shubham Adhikari.
Shivam Adhikari.
Shivam. Okay.
Yes.
Shivam. Okay.
They are the center people. They are directing someone else.
Shivam, you are not on other device, right?
Sorry, sir.
You are not using any other device, right?
So there are 2 devices actually. The laptop is kept over here of the school, and one big screen of television is kept this side.
Okay, fine. Not finished. We'll know. Okay, Shivam, so get ready. Your time starts now.
Okay, so good afternoon, everyone. Shivam Adhikari this side, and I will be speaking on the behalf of St. Joseph's College. Well, talking about greenhouse effect, first of all, what exactly is greenhouse effect? A process through which the surface of the Earth is getting warmer. Now, I'll be distinguishing between 2. One which was natural, and other which we humans have actually increased. So basically, what exactly was there was that there was a layer of the gases, the greenhouse gases like carbon dioxide, methane, and nitrogen. So basically, we all know about the rays which the sun emits from it, and those rays, when they come to Earth, they are very important because those are the rays which will heat up the Earth, and they are very important for the survival. Now, what happens is when these rays come to the Earth, they get emitted inside the Earth, and when they reflect back, so these greenhouse gases, they re-emit them into the Earth. So this is what was the natural process which was actually happening. Now, since we humans, we always do great job in every field. So what we have done by burning fuel, by burning a lot of coal on our Earth. So what is happening is the amount of these greenhouse gases, these have increased in the atmosphere, and since the layer has now thickened, so the ray emission of these rays which come from the sun, they are now in more quantity. Now, first of all, why do we need this greenhouse effect? The very important reason is that if there would have been no greenhouse effect, right now we wouldn't have even existed, because right now the temperature of the Earth would have been minus 18 degrees Celsius, and it would have been really difficult for each one of us to survive and even talk to each other right now. Now, if I would emphasize on the Paris Climate Agreement, or the other treaties which our Prime Minister has even signed. So let's talk about the Paris Climate Agreement, which was signed in 2015. Why do we need to sign it? We actually need to survive. We want the future progeny to see this beautiful Earth. We do not want this Earth to get extinct, and we do not want our children to not even see one single tree, or the glaciers to even melt. Now, if I talk about the state where we all belong from, that is Uttarakhand. The recent glacier that was melted, and what disaster we have seen, that was also a reason which happened because of this greenhouse effect. Now, if I talk about how we do
your time's up.
Time's up. So can I conclude with it?
You want to continue?
So how much time is that? 30 seconds or
Time is finished. Yeah. So you were given 2 minutes, and 30-second warning was given to you. So probably you didn't hear that, but it's okay. You spoke very well. So that's all right.
Okay, sir. Thank you, sir.
Nice. Okay, so we already finished 2 rounds of extempore talks. So this is the final round. And we'll again start with Birla School.
Okay, so the topic is effect of lockdown on pollution.
Okay, so Birla School, you have to speak on the effect of lockdown on air pollution. Can we have the speakers? Please unmute yourself. Birla Vidya Mandir. Not unmuting. Can you unmute yourselves? Okay, so we'll pass on from here. We'll move on to okay, anyways. Okay, so we'll move on to Don Bosco boys. We'll come back to Birla School later. Okay, so the topic. So the topic is effect of lockdown on air pollution. Don Bosco boys.
No, they have done it before.
Done it. Okay, so we'll change the topic.
Raman effect.
Okay, so Don Bosco boys, nominate one of the students for Raman effect.
Am I audible to you?
Yes, you are audible. Please let us know your name.
Good afternoon, everyone. My name is Ranjot Singh, and I'm glad to speak on the given topic, that is Raman effect.
Okay, Ranjot. So your time starts now.
What is Raman effect? According to it, when an incident light interacts with a molecule, energy is either gained or lost. Energy is either gained or lost, so that the scattered photons are shifted in the frequency. This inelastic scattering is known as Raman scattering. On the other hand, if we talk about Rayleigh scattering is responsible for blue color in the sky. According to it, when an incident light interacts with a molecule, the predominant mode of scattering is elastic scattering. The difference between Raman scattering and Rayleigh scattering is that Raman scattering is an inelastic scattering, whereas Rayleigh scattering is elastic scattering. Raman scattering depends upon polarizability of molecules. Secondly, if I compare Raman scattering with air pollution, so there are various devices that are made that have been developed on the base that works on the principle of Raman scattering. A scientist named Lin Xingye at Nanyang Technological University, Singapore, along with his teammates, have developed a device that works on the principle of Raman scattering. This device works on the principle of GCMS, which stands for gas chromatography mass spectrometry. This device helps us to identify air hazards such as sulfur dioxide, benzene, which are harmful to human health.
30 seconds.
This device helps us to identify air quality in detection of gas leaks and industrial air pollutions, especially in Southeast Asia, because countries in Southeast Asia are more responsible for pollution in the air. The technique used by this device is quite reliable, but it requires few days to give the output. So in emergency scenarios like natural disasters, we need fast and ongoing analysis of air contamination. Thank you. So this is what all I know about Raman effect. Thank you and have a nice day.
Next speaker will be from Don Bosco Girls. And the topic is
Mars mission. Greenhouse effect.
Yeah, okay.
They can do it. Okay, so Don Bosco Girls, one of you have to speak on greenhouse effect. Don Bosco Girls, please unmute yourself.
Video is there, but the audio is not there. I think they're not unmuted.
We'll discuss the way it could
वो वीडियो भी ऑफ हो गया ओके वीडियो आ गया है ओके हाँ ओके सो प्लीज लेट अस नो योर नेम not can you please repeat
Am I audible?
yes you are yeah. Yes, so please let us know your name first.
Sargam Soni.
Sargam Soni. Okay, Sargam. So shall you speak on greenhouse?
Good afternoon, everyone.
Wait. Let's start timer. Okay, so the timer starts now. Yeah.
Is it delaying the audio?
Start. Okay. Can you hear us? Can you hear me?
Internet slow. Internet का problem चल रहा है.
उनका ऑडियो कनेक्टिंग
वो डिस्कनेक्ट हो गया उनका वीडियो वो बैंडविड्थ का प्रॉब्लम है
कौन से लिया है वो
अभी आ गया
Can you hear us?
Yes, sir. Yes, sir.
Okay, so are you ready to speak?
Sir.
Okay, so your time starts now.
The greenhouse effect.
You can turn off your video if the internet is not very fast. अच्छा वो
Negatively active gases, that is, greenhouse gases in a planet's atmosphere, radiate energy in all directions. Part of this radiation is directed towards the surface, thus warming it. The intensity of downward radiation, that is, the strength of greenhouse effect, depends on the amount of greenhouse gases that the atmosphere contains. The temperature rises until the intensity of upward radiation from the surface, thus cooling it, balances the downward flow of energy. Earth's natural greenhouse effect is critical to supporting life and initially was a precursor to life moving out of the oceans onto land. Human activities, mainly the burning of fossil fuels and clearing of forests, have increased greenhouse effect and caused global warming. The planet Venus has experienced a runaway greenhouse effect, resulting in an atmosphere which is 96% carbon dioxide and a surface atmospheric pressure roughly the same as found 900 meters underwater on Earth. Venus may have had water oceans, but they would have boiled off as the mean surface temperature rose to current 735 Kelvin temperature. The greenhouse effect as an atmospheric mechanism functions through radiative heat loss, while a traditional greenhouse as
इसमें ठीक ही बोला अच्छा बोला
उनको कनेक्शन चलेगा
selection of the content is also unique. I mean, they're not saying this definition बोल नहीं रहा है.
That was nice. So the next speaker is from Parvati Prema Jagati. So please get ready, Parvati Prema Jagati, and the topic
And the
is.
topic is effect of lockdown on air pollution.
Yeah, they are. Yeah, you want to say something? Yeah.
Sir, Vidya Mandir, we just missed a chance because our net connection was lost.
Yeah, sure. We'll come back to you. So.
Okay, thanks.
Okay. So topic is.
Effect of lockdown on air pollution.
Okay, so you have to speak on the effect of lockdown on air pollution. Speaker, please let us know your name.
Good afternoon, sir. Am I audible to you?
Yes, clear.
Should I start?
Tell us your name first. Tell us your name.
Good afternoon, sir. Myself, Sujanya Kumar, and I am from Parvati Prema Jagati, presenting the topic effect of lockdown on air pollution.
Okay, so you may start now.
Air pollution. Air pollution is defined as the dust or pollutants present in the air. It is being caused by factories, spray cans, vehicles, and many other. The main cause of air pollution is vehicles. From 19th of March, a very bad time has come, and that is a very pandemic disease named coronavirus. Because of coronavirus, the lockdown has been occurred in all over the India. As the lockdown is occurred, so running of vehicles has been stopped in our India. As the running of vehicles have been stopped, so because of this, the air pollution has been reduced. On a survey, the air pollution reduced in this 8 month period was 400% of the last 8 months. So lockdown causes a very large decrement in air pollution. So here we can conclude that by decreasing the number of vehicles, we can reduce air pollution. Thank you.
Okay, so next we have from Sherwood, and topic is
Raman effect.
Raman effect.
Good afternoon, sir. Anmol Mahajan.
Anmol Mahajan, right?
Yes, sir.
Okay, Anmol Mahajan will speak on Raman effect, and your
Yes, sir.
time starts now.
Good afternoon, everyone. My name is Anmol Mahajan, and I'm representing Sherwood College, Nainital. Today, I would like to express my views on the topic Raman effect. When a light beam is shown into a liquid or gas, some of the light particles called photons hit the molecules of the liquid or the gas, and then they get deflected. This change in the wavelength of light is called Raman effect. Eminent physicist Dr. CV Raman discovered this while conducting an experiment on light scattering with student physicist K.S. Krishnan on 28th February 1928. For this discovery, Raman was awarded the Nobel Prize for Physics in 1930. Raman scattering is perhaps most easily understandable if the incident light is considered as consisting of particles or photons with energy proportional to frequency that strike the molecules of the sample. The light source used in Raman spectroscopy is a laser. The laser light is used because it is a very intense beam of nearly monochromatic light that can interact with sample molecules. When matter absorbs light, the internal energy of the matter is changed in some way. Raman effect takes place when light enters in a molecule and interacts with the electron density of the chemical bond, causing electromagnetic field in the molecule, leading to vibrational and deformation of frequency shift. The incident photon excites the electron into the virtual state. Some of its applications are like it helps in the distribution of a compound within a tablet. It helps us in the identification of various minerals and precious and semi-precious stones. It helps in the study of a bony structure, and it also helps in the analysis of a biocompatibility of a material. Thank you.
So the next speaker is going to be from St. Joseph, and the topic is
Greenhouse effect.
Okay, so
Mars mission.
okay, so St. Joseph, one of you will speak on the mission to Mars. Please unmute yourselves.
Good afternoon, sir. Shivam Adhikari will be speaking.
No, Shivam, you spoke already.
You already
right?
spoke, right?
Sir, is repetition allowed?
No, repetition is not allowed. So there are 4 students. None of you want to speak apart from Shivam.
Let's keep
we can ask.
Okay, so if no one is willing, then Shivam, you may continue.
Change the topic.
Okay,
if someone else
so if
wants.
someone else is ready, we can change the topic also.
Yes, so you can change the topic if it's possible.
So apart from you, none of them are interested.
So this will be the last chance. Okay. Effect of lockdown on air pollution.
Okay, so the effect of lockdown on air pollution.
ये तो बोल ही सकता है कोई भी।
Okay. Effect of lockdown. Okay, so the topic is effect of lockdown on air pollution. Anyone wants to say?
So Harsh, but also spoke. No one else is prepared with that topic. If it's possible, can I only speak?
Okay.
Okay, then you might. So which one first? This one or that one?
Let him be confident about whatever.
Okay, so Shivam, you may start.
So could you repeat effect of greenhouse effect?
No, the effect of lockdown on air pollution.
Okay, sir. So can I start?
Yeah, you may start now.
Okay, so good afternoon, everyone. Shivam Adhikari this side, and I'll be speaking on the behalf of St. Joseph's College. Well, if I talk about air pollution and the statistics which were prior to the COVID case or after the after the lockdown, well, air pollution was on the not on the same level. Definitely, if I say that no vehicles were moving, all were like stable. So it was like everyone was vacant. Animals could easily breathe. After all, humans were kept inside their homes. We were all locked inside our homes. There were no vehicles, no coal was burning, no factories were there. And one of the most important things, the trees were safe and the amount of oxygen could have been easily coming from there. So if no carbon dioxide was released, if there were no automobiles, no cars moving, then it was so easy for other life as well, like animals, to survive in that. Now, it was COVID-19 somewhere or the other got a very positive impact on our lives because we were sitting at homes. The evils actually, we humans are the evils. We are not the saviors of this earth. We are anyhow ruining this earth. So we were sitting at home, nothing was going on, and the atmosphere was changed. If we see, not only focusing on the air pollution, if we even see the purity level of River Ganga or even River Narmada, even they were purified. Even the dirty or the bacterial things were reduced to such that it was shameful for each one of us right now that what we have. So 30 seconds left.
Yeah.
Okay, sir. What we exactly had done and what if we are not there, everything is improved. If we see what are the birds or if we see animals who could not easily even breathe. If I talk about Uttarakhand especially, we do not see sparrows. We do not see any those common birds. There were common birds, but somewhere or the other in this lockdown, just because there was not much of the air pollution, we could see the sparrows again. And I would just like to conclude by saying we humans are the actual evils who are ruining this earth. So if we could control ourselves, this earth would have been better, and it will be better if we all together are ready to do so. Thank you.
Okay. So now it's time for the. So now it's the final speaker. So it will be from Birla School. So please get ready. And the topic is
Effect of lockdown on air pollution. दो ही बचे हैं. Extraterrestrial life, exoplanets.
okay. So Birla Vidya Mandir, one of you has to speak on extraterrestrial life and exoplanets. Aliens. आ सकते हैं.
Am I audible, sir?
Yes. Okay, so can you please give us your name?
Can I start?
Your name, please.
Sir, Pranav Vashne. Pranav Vashne.
Pranav. Okay, so Pranav, your time starts now.
A very cordial good afternoon to the august gathering present here. Are there other forms of life present in our space and galaxy? Can human civilization dwell in other interplanetary spaces? Well, the most plausible answer to these questions is that there exists no perfect answer to these questions until or unless we explore the whole galaxy, which isn't possible. One such paradox related to this theory is Fermi paradox. It was given by an astrophysicist, Enric Fermi. This paradox states that how come it is possible that human beings haven't interacted with any extraterrestrial life yet? Well, there can be many possible answers to this paradox. The three major possible answers are: first, human beings are the most intelligent creatures and no other creature is as intelligent as human beings.
Second, human beings are the first ever life form to have ever existed. Third, the other creatures are so intelligent that they are already observing us and giving us signals after signals, which is dwelling our history. Now, there have existed many forms of life before human beings, which have been larger and which could run more faster than human beings. But the human beings are the most intelligent creatures on Earth. It is fascinating to know that that Earth accommodates many strange creatures like sauropodzoids. Sauropodzoids are considered as one of the most intelligent dinosaurs to have ever existed. It is so fascinating to see that earthly creatures like tardigrades can dwell in space, which gives us motivation to explore more and more in space. It would be wrong to conclude that extraterrestrial organisms do not exist, because it is like taking a spoon of oceanic water and declaring that sharks do not exist. It doesn't make sense. So we need to explore our creativity and need to have a comprehensive approach towards our experimentation. At the last, I would like to express my gratitude to Aries and Birla Vidya Mandir to give me an opportunity to express my knowledge in a creative form. Thank you.
So with this, we end this session. So we had a total of 18 speakers for this. And before we proceed for the next event, we'd like to let you know that the results will be announced soon. So with a round of applause for all the speakers for this event. Okay, so let's move on to the next event now.
Yeah, so thank you very much. And I think we will take a while to announce the results. Maybe I would request Director ARIES to kindly announce the results when he will be delivering his concluding remarks. During that session, I think we would announce the results. With this, I think the most important topic of this afternoon session is now to hear about what's going on in atmospheric sciences and what kind of research is going on and what is the balloon-based experiment and so on. So to maintain the time, I would request Dr. Manish Naja, our senior scientist, to cut the overall stuffs and convey the message. So Dr. Naja, please. Well, the PPT.
Minimize.
No, just minimize.
Mouse with the
यहाँ डेस्कटॉप में
वो साइंस डे इसके अंदर साइंस इसके अंदर
ये पहली वाली ना
नहीं हाँ ये स्क्रीन शेयर करना है
ओ हाँ स्क्रीन शेयर करना
हाँ सर
Can you all see the screen?
Yeah.
Yes, sir.
Okay. Good afternoon. So now in the second session, we will be having the talk on the balloon experiment, and which we are doing at ARIES on regular basis. So to start with, basically, what is this balloon experiment and why we are doing this? So this balloon are basically released to understand or study our atmosphere using the scientific instrument. And we put instrument means like this word I will be using frequently, that payload. And when I say the studies, basically we are interested in the weather and climate change and air pollution study. To make this study, we measure the temperature, humidity, winds, and pressure and trace gases in the atmosphere. And now when I say the air pollution or weather change, climate change, now this is more important for our region. Like if you see the recent incident in Uttarakhand, where you had the basically cloudburst or the recent glacier break. So this kind of study is more important for the Himalayan region. And now to come back, like to start this kind of study, we need to understand the vertical distribution of different parameters. And here this shows the temperature distribution of the, I think so here you can see the vertical distribution of the temperature. And this terminology, I think you might be knowing, the troposphere, stratosphere, and the mesosphere. So relate with this our balloon experiment, like to get this kind of profile, you need to have the experiment to have the vertical distribution of this parameter. And you can see this profile is basically combination of two set of experiment. One is the balloon, which is basically capable of the measuring the temperature from surface to around 30-35. Then above that is rocket. So basically, this is very important part. And what I am trying to say here, this kind of studies goes to give the important input for the air pollution and climate change study. Now, the another aspect is the basically one of the pollutants in the atmosphere, the ozone. Now, when I say the pollutants, it is the basic pollutant in the lower atmosphere, but it is very important gas in the upper atmosphere or in the stratosphere. So this also basically we obtained by using the balloon, this kind of profile. And to just refresh your memory, like this ozone in the stratosphere, it is basically formed by the photodissociation of the oxygen molecule. And this is good ozone we call, and this is almost 90% the atmosphere. Whereas if you see the another ozone, which is the pollutants, and we call it the bad ozone. And this is almost the 10% in the atmosphere. And this bad ozone is formed from the photochemical reaction using the different pollutants in the atmosphere, like carbon monoxide or NOx and hydrocarbons, all these things. So to see the why we say the bad ozone, like this is the showing the impact of the bad ozone when it is in air, it is in high level. It goes in the human beings, when you breathe, it goes in the lungs and it oxidizes the lungs. And you can see this is the normal lungs here, and then this is the basically inflamed one. So oxidation process, chemical process, make the damage in the human body. And apart from the human, this also having the impact on the vegetation. High level of ozone, they degrade the quality of the plants. And ultimately, when you have the degradation in the quality of plants, the degradation of the growth is also seen. So that is basically in different vegetation, you have the significant reduction in the growth. Now, so to again, like to go in the history, like the ozone was basically discovered by the one German and Swiss chemist Sonnenwende. And this, but important point, the Sonnenwende in 1840, he thought this ozone is made of the oxygen and the hydrogen. But after around 20 years, the Orling suggested that it is not basically made of oxygen and hydrogen. It is made of the 3 atoms of the oxygen. Now, this was the basic theoretical discovery. And then after the almost 40-50 years, the Chapman gave this mechanism, which he defined the Chapman mechanism for the ozone production and the ozone loss. Now, why I am telling this important point, like this is giving the link to the ozone loss mechanism. Now here, this simple mechanism is not leading to ozone loss, but there is another mechanism which got the Nobel Prize in the discovery in the 1970 and 74, and that discovery was made basically the additional mechanism which discovered for the ozone loss mechanism. And this is the basically catalytic ozone destruction in the stratosphere. And when he said the X molecule, which is the radical in the atmosphere, this can be the CFCs or the nitrogen compound. When I say CFCs, basically this is the chlorine, chlorine, or the atmosphere we have this kind of thing. So this is the basic important point. This is the catalytic reaction. So once it starts, the ozone, you can see the destruction is continuing. Now to understand this process again, and also in seeing the Antarctic region, like this ozone loss is basically seen in the Antarctic and particular season. It is basically seen in the winter time, or you can say in the early spring. So this is the example showing how the ozone loss is seen in the Antarctic. And this is the Antarctic means from July to September, and October, November, December, and the ozone loss is very minimum in the springtime. So main mechanism you see theory wise, the ozone production and loss is happening. But in the Antarctic, when we know that it is almost the dark for the 6 months, so you don't have the solar radiation enough for the production. So this is the basically period you have the ozone loss. And now this is basically, you can see ozone loss is seen after the 1980s or the 82, 83. Until 1971, the ozone was basically almost in the same level. And this is basically discovered in the observation in the Antarctic. I will skip this slide. The observation over the Antarctic made by the British team. Like they have the total ozone observation in 1960, 70, and after that they started seeing that ozone loss is happening and coming to almost the 150 or 160 unit. And of course, the same time, the Japanese group was also making the observation, but they were not confident in their finding, and somehow it is first reported by the British group, and they published the paper in the scientific journal. Now here the next slide I'm trying to show you one important the slide. This is also linked to our region. Now until in the previous I was mentioning the ozone loss was shown by the ground-based observation, and this is for the first time one scientist, Indian scientist Pavan Bhartiya, he combined the satellite-based observation, and for the first time he made the picture of the ozone hole over the Antarctic in 1985, and this is the combination of the different satellite data. And now when the connection of this Pavan Bhartiya goes to one of the school which is attending the school here, the Birla school. He was the basically student in the Birla Vidya Mandir in 1960s, and his name is also, I think, student can see on the board. He was the basically topper in the 12th class that time. So I have seen his name on the board also. Now presently he is senior scientist at the NASA GSFC, and now still very active at the age of the almost 75. And now, so coming back to this ozone hole over the Antarctic, here I would like to show how balloon experiments are useful, like to finding the ozone, why ozone hole is more important over the Arctic or over the Antarctic, not the Arctic. There is the one temperature condition we call the polar stratospheric cloud, and this temperature of the polar stratospheric cloud is very basically, you can say the temperature goes below -78 degree. This cloud formation is taking place, and such kind of the cloud formation is more over the Antarctic, and the CFC which are released in the atmosphere, they trapped in the very large amount in the Antarctic. So that is the reason basically you see the ozone hole or ozone loss more over the Antarctic, not over the Arctic region. Now, so again to relate with this, like why we are interested in the balloon experiment, like the immediate link for the balloon experiment goes with the observation which is made for the CFC. Now that I will be linking in this later slide. So here I am trying to show what are the different balloons are there. So one can categorize in almost in the 3 or 4 groups. Like this is the high altitude balloon, and there are very limited facility over the globe, and this balloon goes up to almost the 40 kilometers. And but important point in this, you can have the payload of almost 2,500 kilograms. There another category is the weather balloon, and these are the basically for the very small payload, and where payload weight can be almost from 500 gram to 2 to 3 kilogram, and the altitude is slightly lower but not much. And these are the 2 categories which are mostly used for the scientific research. And the other category is the tethered balloon, which is basically used for the multi-purpose. Even for the tourism, you can see the hot air kind of balloon. So apart from the scientific study, this can also be used for the pleasure trip. Now, another experiment is going on in the USA, that NCAR group, they are planning the super pressure balloon. Now, this balloon, you can say this is the artistic view here, and there is basically plan like this kind of experiment can also reduce a lot of cost when you have avoid the satellite observation, or basically you can have at low cost the very high quality of the observation, and they are capable of having the payload of almost 1,000 kilogram, and the altitude from 30 kilometer to goes to 40 kilometer. So these are basically some of the basic thing, and which is going on now. So I am coming back to the weather balloon where we are interested more, and our scientific research goes. So on statics wise, like globally, there are almost the 9,900 stations where these weather balloons are being launched. And you can see every day almost the 2 balloons are launched. out of this 4 time zone. These are the basically global classification. So you can say work out almost the 6 lakhs, almost 6.5 lakhs of balloons are launched every day around the globe. Now, out of the 900 locations, the India is having the 39 stations, and these are operated by the Indian Meteorological Department. So when I divide this weather balloon basically in 2 categories, one is the basically mid altitude and the low altitude, and the major difference is basically in the payload. Like what is the basically observation or study we will be doing. So in this mid altitude the balloon, we have the basically gaseous instrument and the aerosol apart from the meteorology. Whereas in the low altitude, you have the basically on the meteorological the payload. So here I'm trying to show here one typical example of the high altitude balloon. And this in India, there is only one facility at Hyderabad, and this is basically established by the TFR group. And here you can see the one typical example of this high altitude balloon, which goes almost the 40 kilometer to 50 kilometer altitude. And you can see the size of the balloon. You can feel here like this is the scientists or the technical people are standing, and this height of this balloon is almost, you can say it goes to 120 meter height kind of thing. Now, if you break up this height in the different sensor, this is the composite diagram. You can see this balloon, which is the height of almost the 30 to 40 meter, depending on your interest in the research. And there is parachute is linked with that for the safety purpose. And you can see that there are different radius on day and the radar reflector. And there's some rope basically to breathe, like when you have some movement in the air. So this payload doesn't hit the balloon or the parachute. So this is the basically heart of the scientific instrument, which is at the end, you can see. And the one typical example I'm showing here, which is basically linked with the study on the CFCs, which is basically destroying the ozone. And this is the one, the cryogenic sampler, which is flown on this kind of the balloon at the altitude of almost the 45 kilometer. And this payload of this payload weight of this cryogenic sampler is almost 1,000 grams. And here you can see this one actual picture of the payload. Some of the scientists and the technical people are working. And you can see the height of this payload is almost 6 to 7 feet here. So this is basically one scientific experiment done in the Hyderabad. And this is the only facility in India. Now, another breakthrough of this balloon experiment why the TFR balloon facility was made, basically launching this balloon up to the height of almost the 51 kilometer. And this is the only USA and Japanese scientist or the technical team has performed. And this is basically to have this some test experiment in the crossing the almost stratosphere. And this is done in 2014. And you can see the balloon, the size is almost 61,000 cubic meter. The previous balloon, which I was showing here, this balloon size is much higher. This is almost 1,50,000 cubic meter. So this is the much bigger balloon when you see the comparison to this one. Now, the important point in this balloon, these are the filled with the helium gas, as of course we know this is the light, the gas, but the helium is filled not only from the bottom, it is also filled from the top side from this kind of thing. You can see these some channels are here because this gas is very light. So it will take much longer time for helium to go up in the or the top side of the balloon. So this gas is also filled from the top side. Now, this apart from this continent region, this such kind of experiment is also done at the remote places. So this you can see over the Antarctic region. Such kind of weather balloon is also launched. Now, this is like, as I was mentioning previously, the balloon are launched almost the 2 times or the 4 times in a day. So many times you have to have launched on the midnight. And so the different country has also set up the facility for the auto launch of the balloon. So this I would like to show here a movie which shows how the auto launch is done. Like auto launch is basically when you have to launch the balloon at the midnight. So this is the one, the setup which shows the launch of the balloon.
No, link. Go to the hyperlink. Okay. Back.
Yeah, so this is the basically over the facility which is in the UK is made, and here you can can see this is the actual payload. This is coming out automatically. And at the certain time in the midnight, and this is getting connected, and this is done totally unattended, and then gas is being filled in the balloon here automatically. And this is the basically door. When this at the command it will open, and you can see the automatically the balloon will be launched. So this kind of arrangement is done when you have the launch at the remote places or in the odd hours, like in the midnight kind of thing. And here you can see the balloon will come out automatically. So this is totally unattended experiment. But this kind of the automatic launch are basically done only for the weather balloon, and when balloon size is very small. Okay. And here I'm coming back to the facility which we are having at the ARIES Nainital. This is also the weather balloon at the mid altitude, and this is the actual balloon which are launching from this place, and this is the balloon filled with helium. Now, sometime apart from the helium, we also use the hydrogen gas. This is the parachute, and this is the actual sensor at the bottom side you are seeing, and the sensor which also we call the payload, which is having the ozone sensor and the meteorological sensor we call the radioson. So here basically more detail on the sensor side, like this is you can say the layout of the sensor. This is basically two parts. This is the meteorological sensor, or we call the radiosonde, and this is the ozone sensor we call the ozone sonde, and this is made of the thermocol kind of thing to make it lightweight. And you can see here the total weight of the sensor is almost the 500 gram. And here just to give you an idea how this the sensor works in case of ozone. This is the very small size of the sensor. Almost you can see the 4 inch of the height of the sensor. And this is the one small motor is fitted here, which is operated by the battery, and it sucks the air inside from this tube. And there is based on the chemical method. So there you can see the one anode and cathode is there, which is filled with the solution. So when ozone enters in this chamber, we have the chemical reaction, and then which is ultimately release the current. And in the slightly more detail, this entire mechanism you can see here, that here you can see the two chamber, one is the anode chamber and cathode chamber. This is filled with the potassium iodide solution. So when air goes inside, which is having the ozone, it reacts and lead to the ionization of the basically free iodine is released in this process. And now this also basically you have the generation of the current, and depending on how much ozone is there in that, you have the basically generation of the current, and you measure the calibration of the current. And based on that, you calculate the ozone amount. So this is the simple experiment which we are doing at ARIES. Now this is I'm trying to show one typical result. The balloon which goes up to the almost 35 kilometer height, and here you can see from surface, this is the ozone level here on blue color, and this is the basically troposphere going in the stratosphere, where the ozone level is in the ppm is almost the 10 to 12 ppm here. This is the basically ozone layer region, and here is you can see the red color showing the temperature. This is the tropopause here. When above that it goes the stratosphere, and this is the humidity. And as expected in the lower the surface level, the humidity is very high, almost 70 to 80%. And when you go up, it is almost dry air, which is coming to less than 10%. And the next time we try to show this the movie, which is showing how the balloon is launched at the ARIES Nainital. So this is the basically actual demo. Oh, okay. So I will make it pause, but I don't make no, but actually I just wanted to explain this the laboratory setup here. So this is the actual laboratory setup where this payload, or you can see the ozone sonde or radio sonde are prepared. So here you can see the small sensor. This is the basically actual ozone sonde, which is filled inside this the thermocol box. And this is the basically you can see ozone unit, which is used for the calibration purpose. and you can see in the chemical solution. So the potassium iodide solution, which is filled in this the anode and cathode solution. So this is basically preparation. We start almost, it takes almost 1 hour to prepare this kind of the sensor. And here you can see the unit of receiver, which is basically used for the receiving the data. So when we start the launch, the preparation. So now here you can see the one by one, like this is the antenna to receive the data. So the entire data is basically received online. And here this is preparation of the balloons being, you can see here. And on this side, you can see this sensor is almost ready, which is kept this side, this ozone sonde and radio sonde. So you can see here, because we are not having the fully automatic arrangement, so it takes a lot of effort to fill this balloon. And because of the wind, people has to hold it. So you can see when gas is being filled, and we have to control this balloon because the balloon should not drift. And you can see the diameter of this balloon is almost 1.5 meter. So this is the mid-altitude balloon. So balloon is almost ready, and they are just checking whether the hydrogen is almost completely filled or not. So this person is testing by seeing the pressure, because there is some also test load is there. Now the sensor is ready, and they are tying with the rope and making ready for the arrangement. It is almost ready to the launch. So this is the first time, and now here you can see, now here one critical point, you can see the release has to be done very slowly, and suddenly it should not go. And so this is ready to launch balloon. The balloon and the parachute and sensor is here. This one white box, and this is released. So it's going in the atmosphere. So this kind of balloon, this goes almost, depending on the weather condition, the pressure, almost 30 to 35 kilometers in the atmosphere. Now the data is almost reached the ground. So then we do the analysis using this kind of thing. So I think that's all for this. And I hope I managed within the time.
Yeah.
So
yeah, thank you, Dr. Manish, for your very elaborative talk on the topic, and that what kind of science is being done and what kind of activities are there. Now it is requested by the audience, particularly the students, to ask questions if you have on this branch of science which we are conducting here at ARIES. Students.
Yeah, if you have questions, you can unmute yourself and ask the question, or you can use that raise hand option also, which I mentioned earlier, from the reactions icon at the bottom.
You can also type in the chat box. They want to keep the time.
They're getting tired and they're waiting for the results.
Possibly getting tired. Students, teachers, do you have any questions?
Yeah, it's there.
Because yeah.
Sir, what material of balloon is used for experiment?
yeah, so there are basically different materials, like to start with the people use when the polythene was used. Now the recent one, the Japanese use some kind of Teflon material. And the important point of this material, it is very thin. The layer of this is almost 3 micron kind of thing. So it is much thinner than your the hair. So now mostly people use the rubber or the Teflon.
Yeah, anybody else? Teachers? Do we have more questions from students before we invite our director for concluding remarks? And results of extempore session. I hope you are still online, students.
teachers?
Yes, sir.
Okay. So they are basically interested in results. Yeah, very good. So now I would like to invite Director ARIES for his concluding remarks for the day and announce the results before we adjourn the session. Sir.
Okay. So there I am. So I must say that it has been quite an enjoyable day for me, and I'm really thankful to my students to start with. I think in a very short interval of time, they made a lot of arrangements, and the movies that made about the institute, I'm really proud of them. Because we have done movies in the past with professionals, but this approach is very different. It is very lively. I really like. I only mentioned to them 2 days back that I want something like Walk the Talk in NDTV. so they conceived this entire idea, and whatever material we have, they have collated that and they have made this movie. So I'm very thankful to them, and I also am enjoying the way we are able to participate in this difficult time. So hopefully we are coming out of this pandemic, and next time it will be even more interactive. You will not have any place in this auditorium to sit. I'm looking forward to that kind of opportunity. So students, those who have participated throughout the day, thank you very much for coming through this virtual media. But I promise that I would love to have all of you in campus here and meet you face to face. I hope that situation becomes a reality in coming months. So the time. So here I have the results. I think it was a fantastic performances from the students, and also the morning session. I was actually feeling that maybe we should have a longer quiz time. Next time when we plan something like this, we will we'll keep a longer time duration for that. So what the judges and the students who were scoring decided that it was really hard to make a decision in terms of this extempore competition or participation. I would put it that way. So we are giving the sort of ranking in terms of the schools. Primarily 3 schools are getting the school prizes, and there will be special mention and special prizes for some individuals, which we also we would like to make, and we would like to have some interactive session with them, maybe in person in coming month, because as you know that we here are restricted to not to meet too many at a time, but we'll send our invitation to some of these specific names which have been given, so which can allow us to just start interacting with you, and subsequently we will ourselves visit your school and we'll give lectures and have further interactions. But this is a special award, I would say, that the specific names which I will be announcing, we will make opportunities for them to come and visit us. We will make a specific date. I mean, looking at your convenience in the sense of your classes and so on, and we would love to interact with you. So here are the results. So the first prize goes to the Don Bosco girls. Second,
on the video.
yeah, so Don Bosco girls, I see them, rejoicing. Very nice. The second prize goes to Billa Vidya Mandir. And the third school prize goes to St. Joseph College. So as it was mentioned earlier also, you see, of course, at the end of the day, if it is a competition, there will be some individuals or schools as ranked as 1, 2, 3, but we all appreciate your participation most, and it always gives you opportunity to do better or get more prepared with those experiences what you have. And this time through these online resources and restrictions, it's hard. We do understand the network issues and so on, but we were overwhelmed with some specific performances, and all the judges are almost unanimous in this. And we are coming to the individual special prizes, and the first prize goes to Ashmi from Don Bosco Girls. The second prize goes to Shivam from St. Joseph College. And there are 3 individuals who are in the third because they were so close, almost not even second place of decimal. So the committee decided that all the 3 names will be considered together. So that's Anman from Sherwood College, Pranav from Billa Vita Mandir, and Sangam from Don Bosco Girls. So I'm personally very happy to, you can pin them probably. All of them are that, yes.
So they can identify light from
Yeah.
downwards.
So probably I will give, we have heard and we are very impressed with the capabilities of. But we'd like to hear comments from Ashmi first. So can you unmute yourself and say a few words? We are not able to hear you. Oh, sorry. Our volume has to be increased probably. Yeah, sorry. Just wait a minute. Yeah, can you try now? No.
I think there's a problem at that end.
That end? Are they unmuted?
Wait.
Don Bosco Girls? No, their thing is.
Sir.
It's frozen. Your microphone is,
not.
Yeah.
There's some issue with them.
There's some issue with the microphone. Yeah, we are not able to. Yes, now we can hear you. Yes.
Yeah, so this was a great experience, and I'm very thankful to my school and ARIES for giving me this opportunity, because space has always been an interesting topic for me since I was a kid. And now that it is like AI is very advanced in this field, so it was a great experience. I'm glad to have participated. Thank you.
So Ashmi, you are most welcome to visit us, and we will schedule that sometime in next month. And since you mentioned AI, some of us are working on AI because astronomy gives you opportunity of big data. So this is one particular application of AI and ML. Using the astronomical data is real. We do have some projects. So if you are interested, we will tap you in. Thank you very much.
Thank you.
Let us now hear something from Shivam. St. Joseph.
Good afternoon, sir. Good afternoon, everyone present over here. So first of all, I would like to thank ARIES for organizing this big event. And it's like congratulations from St. Joseph's College, because it was a very good and a successful event. I would also like to thank my teachers, Mr. Digama and Mr. Tiwari, who gave this opportunity to me that I could come over here and speak. And also regarding the topics which were given to us, they were amazing. Like for the first time when I saw them, it was like great. And we would love to come there and visit ARIES. And also a request from us, like keep on organizing these events and we will definitely participate in them. Thank you so much, sir.
Thank you very much, Shivam. We will definitely make more provisions for such events, more regularly. Let us hear from Anmol from Sherwood. Anmol, if you are there in Sherwood. Sherwood is looking. Is Sherwood there? Could you see Sherwood? Yeah, maybe I can't see Sherwood. Okay, we'll get back if Anmol is back on nice Sherwood. Yes, Virendra, some boys here. Okay. Yeah, let's go to Brilla then. Pranav, if you are there, we would like to hear your feedback. You have to unmute yourself.
Sir, it was really fascinating to take part in this event. It was my first science extempore and I really liked participating in it. I would also like to thank Director Sir for giving such meaningful facts. And I also liked researching it. And at last, I would like to thank my school and ARIES for including me in this event. Proud to present.
Thank you, sir.
All the best, and you're most welcome to visit us. Sangam, if you are there from Don Bosco Girls again, you can unmute yourself.
Sargam.
Sargam, sorry, not Sangam. Yeah, Sargam. Yeah, R and N becomes too close.
Sir, it was a very great experience for me. And for this, I am thankful to school and ARIES for giving me this golden opportunity. Thank you.
Thank you very much. So with those words, if there is anybody else wants to make any comment from the schools, their teachers or anyone, we will give this opportunity for that. Would you like to make any comment now before we close formally?
Excuse me, sir. On the behalf of the principal of St. Joseph's College, we would also like to thank you and also thank you for inviting St. Joseph's College. It was a wonderful opportunity. Also for all the presentations which you have presented to us. They were really great and we have learned a lot of things from all those presentations. Thank you so much, sir.
Thank you, Shivam, for your kind comments. And we would love to, as I mentioned, we would love to have more regular, events here, in-house here. And I'm sure you will enjoy it, even more when we have that opportunity. So, is there anything, Shashi, my colleague, Shashi has been the main driving force for getting you all here because, it takes a while to coordinate all these activities. And there are some of my colleagues who have been, working behind. Viren will be taking charge of, this outreach and interaction with the local, schools more regularly. So, yeah, so here is Viren. Yeah, so he's a scientist. He works on atmospheric science, but he is equally equipped with the nighttime astronomy and the telescopes. When you meet him face to face, you will see his knowledge base. And I'm looking forward to those times when we can do that more regularly. So any comments from the students?
Maybe you can quote Haider, who gave a brilliant speech. But
hello.
Okay. Yeah. So I think there is a comment. I think very beginning we were very, very impressed with Haider. The spirit with which, yeah. Somebody has a comment. Go ahead.
That was Anmol.
Oh, acha, Anmol could not get login at that time. Anmol, are you able to speak now? Oh, I see. Anmol, can you unmute yourself and see? We see that you have logged in.
Yes, sir. Yes, sir.
Yes. Go ahead. No, you have again muted yourself. So you have to unmute yourself and then speak.
He may not be knowing that.
Yeah, Anmol, are you able to hear?
Excuse me, sir. He's telling he cannot join. He's not being able to join.
Okay, fine, no problem.
Sir, on behalf of Sherwood College, I would like to thank the director and all the staffs over there for giving us such a good chance for exploring and going into the field of science, astrophysics, and astronomy. We would love to visit your laboratory once. Thank you for all.
Thank you. And it will be a pleasure for us. I know today you had some, network issues also at the different times.
Yes.
So that does make a difference. We can understand that. So next time when we meet, face to face, you can
Yes, sir.
participate more actively. Yeah. Yeah. All the best.
So,
Yes,
thank you, sir.
Thank you,
I
sir.
would also like to express a warm gratitude towards yourself. I'm Ronit Mukherjee, representing Sherwood College, and I've also got a very good information from you guys. I was going to become an aeronautical engineer. This is my target.
Okay.
So I've got very much information. So very much thankful to you. Once I'll surely visit your Aries Nainital.
Sure. So any students from our side have any comments? Yeah, we'll have our party later on. So thank you again, everybody, and I'm looking forward to the next opportunity to have a better interaction. Heather, you wanted to say something, or Harsh? Oh, Harsh Bhatt has raised hand. Yeah, Harsh, you want to say something?
Yes, sir.
Go ahead.
So today we had a discussion about black holes. So we had been researching and I came across this dilation.
There are experts in black hole here in Aries. So please come and have a session with them. We can organize that.
So could a few of you explain why this occurs? The gravitational time dilation.
Yeah, so I will, again, we are very close to the, completion of today's thing, and your audio is also breaking in between. What I would, request you, we will arrange for a session for you with our experts in black hole. You will enjoy it more. We'll do that. Okay.
Sure, sir.
Yeah.
Lecture also.
Yeah. So there are some e-lectures available in our website. You will find Indranil Chattopadhyay. There is in the YouTube channel. You will find some black hole introduction, and there is a lecture of more than an hour probably. You will get more insight into that. So probably you go through that, and if you still have questions, we will arrange a interaction with you with Indranil itself. Okay.
Thank you, sir.
Yeah. Okay, so with those words, I think I will conclude, today's session. Shashi, you have any final?
We can just ask the winners to be there on the screen, and we'll take screenshots.
Okay. If it is possible, and if the winners are still there, can you come into the, keeping your video on? We'll take a screenshot, from our screen here for our records. Of course, your certificates and all that we will send you in the school.
Send Joseph video on. We can speak in it.
Yeah, Don Bosco Girls, Birla Vidya Mandir, and St. Joseph College. And I think they might have left. They might have left. Yeah.
Sir, we would like to thank you on behalf of the Sherwood fraternity for a spectacular event.
You were very good, actually. You were very good. We were the first time, and we were quite impressed. So I'm sure next time you're going to beat the others.
Yeah, thank you, sir.
Okay. With those words, then we will probably, finish the online session. Thank you very much. Oh, screenshot.
All the online participants.
Finish the session. Okay.